I sense, I learn, I act. Driving AI into industries, from cloud-scale model training to real-time intelligence at the edge to physical AI. Systems that perceive, decide, and execute, delivering real-world value. Scaling physical AI and robotics through the perception, reasoning, action, planning building blocks. This is where Advantech comes in, the Edge AI enabler. We deliver the essential building blocks for Edge AI, from AI on modules and AI appliance systems to Edge AI HPC, integrated with powerful software platforms and services. With a strong hardware foundation, software acceleration, and platform orchestration, WEDA. Advantech, together with ecosystem partners, accelerates Edge AI adoption across industries. With NVIDIA, Intel, AMD, Qualcomm, Canonical, and Phison, Advantech brings together compute, software, and cloud-to-edge enablement in one open ecosystem. Powering real-world Edge AI means turning intelligence into action across every environment. Humanoid robots built for real interaction. AMRs navigating with autonomy. Smart manufacturing with 360-degree safety monitoring. Environmental monitoring powered by real-time AI vision. Workplace safety monitoring, detecting risk before incidents happen. And medical AI, enabling precise surgical navigation. Behind every real-world deployment is an open ecosystem, connecting technologies, partners, and platforms to scale Edge AI faster. Partner with us, unlock Edge AI possibilities.
Edge computing and Edge AI bring intelligence closer to where it matters, unlocking real-time insights, agile decisions, and boundless innovation at the edge. Over the years, Advantech has leveraged its top-tier hardware development expertise to deliver industrial-grade designs that meet diverse certifications, ensuring reliability and innovation across industries. Advantech AI software services optimize deployment by pre-testing and integrating sensors, SDK, and language models for seamless implementation. The AI partner ecosystem enhances solution-driven services, accelerating innovation and operational efficiency. Advantech delivers comprehensive Edge AI systems, spanning edge to cloud and supporting both x86 and ARM-based architectures. With scalable AI performance and flexible solutions, these systems enable seamless adaptation to diverse AI scenarios and applications. Advantech Innovation Solution pilot software services bring cutting-edge AI expertise to accelerate industry-wide deployment. By optimizing workflows, these advanced solutions reduce deployment time by 70% from years to months. Through strategic collaboration with ecosystem partners, industry-specific insights drive seamless AI integration, transforming innovation into reality faster than ever. Advantech brings Edge AI to reality.
Advantech embraced the vision of enabling an intelligent planet in 2010, and we embarked on the construction of Advantech AIoT Co-Creation Campus in 2014.
After a decade of development, the campus, combining technology and intelligent design, is now complete. Its rapid campus-style architecture fosters an environment that ignites Advantechers' enthusiasm. Building E, finished in 2014, houses the Embedded IoT Business Group's headquarters. Building M, the Advantech Manufacturing Center, fully implemented Industry 4.0 standards in 2016. Building U, completed in 2023, now serves as the Surface IoT Business Group's headquarters. The Advantech AIoT Co-Creation Campus covers an area of 3.5 hectares, featuring demonstration rooms that highlight our technology and innovation, offering customers access to very best IoT solutions.
This demo room highlights AIoT plus edge computing solutions, featuring Advantech's Edge AI technologies, alongside a range of industrial IoT products and solutions.
Advantech has integrated AI, smart manufacturing, industrial equipment, and energy management systems into its production lines to enhance operational procedures and overall factory efficiency.
Advantech offers an immersive view into what smart cities look like,
which includes intelligent retail, intelligent mobile solutions, and integrated healthcare solutions. Advantech showcased both software and hardware services to create a comprehensive smart city experience.
Advantech embraces the spirit of altruism, creating values for customers and partners. Furthermore, we established a workplace that promotes well-being for employees. Advantech, starting in Taiwan, promotes our product globally, prioritizing altruism and the common good on its path to enabling the intelligent planet.
Join us at the Advantech AIoT Co-Creation Campus to co-create the future of the AIoT world.
Ladies and gentlemen, welcome to the Advantech Edge AI Conference. I'm actually your host today. Just a quick reminder, our event will begin in 10 minutes. Please take your seat. And don't forget to switch your mobile phone to vibrate or silent mode. Thank you for your cooperation.
From cloud-scale model training to real-time intelligence at the edge to physical AI. Systems that perceive, decide, and execute, delivering real-world value. Scaling physical AI and robotics through the perception, reasoning, action, planning building blocks. This is where Advantech comes in, the Edge AI enabler. We deliver the essential building blocks for Edge AI, from AI on modules and AI appliance systems to Edge AI HPC, integrated with powerful software platforms and services. With a strong hardware foundation, software acceleration, and platform orchestration, WEDA. Advantech, together with ecosystem partners, accelerates Edge AI adoption across industries. With NVIDIA, Intel, AMD, Qualcomm, Canonical, and Phison, Advantech brings together compute, software, and cloud-to-edge enablement in one open ecosystem. Powering real-world Edge AI means turning intelligence into action across every environment. Humanoid robots built for real interaction. AMRs navigating with autonomy. Smart manufacturing with 360-degree safety monitoring. Environmental monitoring powered by real-time AI vision. Workplace safety monitoring, detecting risk before incidents happen. And medical AI, enabling precise surgical navigation. Behind every real-world deployment is an open ecosystem, connecting technologies, partners, and platforms to scale Edge AI faster. Partner with us, unlock Edge AI possibilities.
Edge computing and Edge AI bring intelligence closer to where it matters, unlocking real-time insights, agile decisions, and boundless innovation at the edge. Over the years, Advantech has leveraged its top-tier hardware development expertise to deliver industrial-grade designs that meet diverse certifications, ensuring reliability and innovation across industries. Advantech AI software services optimize deployment by pre-testing and integrating sensors, SDK, and language models for seamless implementation. The AI partner ecosystem enhances solution-driven services, accelerating innovation and operational efficiency. Advantech delivers comprehensive Edge AI systems, spanning edge to cloud and supporting both x86 and ARM-based architectures. With scalable AI performance and flexible solutions, these systems enable seamless adaptation to diverse AI scenarios and applications. Advantech Innovation Solution pilot software services bring cutting-edge AI expertise to accelerate industry-wide deployment. By optimizing workflows, these advanced solutions reduce deployment time by 70% from years to months. Through strategic collaboration with ecosystem partners, industry-specific insights drive seamless AI integration, transforming innovation into reality faster than ever. Advantech brings Edge AI to reality.
Ladies and gentlemen, welcome to today's conference. Just a quick reminder, our event will begin in 5 minutes, so please take your seat. And don't forget to switch your mobile phone to vibrate or silent mode. Thank you for your cooperation.
Intelligent design is now complete. Its rapid campus-style architecture fosters an environment that ignites Advantechers' enthusiasm. Building E, finished in 2014, houses the Embedded IoT Business Group's headquarters. Building M, the Advantech Manufacturing Center fully implemented Industry 4.0 standards in 2016. Building U, completed in 2023, now serves as the Surface IoT Business Group's headquarters. The Advantech AIoT Co-Creation Campus covers an area of 3.5 hectares, featuring demonstration rooms that highlight our technology and innovation, offering customers access to very best IoT solutions.
This demo room highlights AIoT plus edge computing solutions, featuring Advantech's Edge AI technologies, alongside a range of industrial IoT products and solutions.
Advantech has integrated AI, smart manufacturing, industrial equipment, and energy management systems into its production lines to enhance operational procedures and overall factory efficiency.
Advantech offers an immersive view into what smart cities look like,
which includes intelligent retail, intelligent mobile solutions, and integrated healthcare solutions. Advantech showcased both software and hardware services to create a comprehensive smart city experience.
Advantech embraces the spirit of altruism, creating values for customers and partners. Furthermore, we established a workplace that promotes well-being for employees. Advantech starting in Taiwan promotes our product globally, prioritizing altruism and the common good on its path to enabling the intelligent planet.
Join us at the Advantech AIoT Co-Creation Campus to co-create the future of the AIoT world.
Edge computing and Edge AI bring intelligence closer to where it matters, unlocking real-time insights, agile decisions, and boundless innovation at the edge. Over the years, Advantech has leveraged its top-tier hardware development expertise to deliver industrial-grade designs that meet diverse certifications, ensuring reliability and innovation across industries. Advantech AI software services optimize deployment by pre-testing and integrating sensors, SDK, and language models for seamless implementation. The AI partner ecosystem enhances solution-driven services, accelerating innovation and operational efficiency. Advantech delivers comprehensive Edge AI systems, spanning edge to cloud and supporting both x86 and ARM-based architectures. With scalable AI performance and flexible solutions, these systems enable seamless adaptation to diverse AI scenarios and applications. Advantech Innovation Solution pilot software services bring cutting-edge AI expertise to accelerate industry-wide deployment. By optimizing workflows, these advanced solutions reduce deployment time by 70% from years to months. Through strategic collaboration with ecosystem partners, industry-specific insights drive seamless AI integration, transforming innovation into reality faster than ever. Advantech brings Edge AI to reality.
AI is reshaping industries. Edge is where intelligence becomes action, and real impact happens only when AI reaches the field. Edge computing brings intelligence closer to machines, to operations, to the moment decisions must be made, real time, on site, without compromise. At Advantech, edge computing is not just a component, it is the foundation for everything else we build. Built on this foundation, WISE powers industrial AI transformation. At its core is WEDA, our developer architecture for flexible development, cross-chip deployment, and scalable implementation. Together, they enable the full industrial AI loop, bringing edge intelligence into robotics and machines that sense, simulate, decide, and act across industrial environments. Across manufacturing, energy, transportation, healthcare, retail, and smart cities. Edge AI brings intelligence into operations, enhancing precision, efficiency, resilience, and automation while turning data into real-world action. With our partner ecosystem, we expand these capabilities into deployable solutions across the industries we serve. Advantech Edge Computing and AI-powered WISE solutions.
Good afternoon to our guests, partners, media friends, and everyone joining us online. Welcome to the Advantech Edge AI Conference. I'm Ashley, your host today. As AI continues to evolve from cloud to edge AI, emerging technologies are rapidly reshaping the future of industries worldwide. Today, we are honored to welcome global leaders and ecosystem partners to share their insights on the latest technology trends, industry strategic, and real-world AI deployments. Thank you for being here and joining us. We hope you enjoy the conference. To begin today's conference, we are honored to invite Mr. Miller Chang, President of Embedded Sector at Advantech, to deliver the opening keynote. His presentation, From Digital to Physical, Edge AI Computing and WEDA, will share Advantech's vision. And then he will invite technology leaders from NVIDIA and Qualcomm Technologies to further explore the next evolution of physical AI. Now, please join me in welcoming Mr. Miller Chang to the stage. Please give him a round of applause.
Hello, everyone. Ladies and gentlemen, good afternoon. I'm Miller Chang. Very excited to see you all here. This week is also the annual Computex. I think everybody is very busy. And the first of beginning, I want to say thank you to appreciate all our partners from global region. Appreciate all your effort for a long-term partnership and also join our event today. I'm very happy to see you here. The first session, I'm going to introduce a very important topic, physical AI. We'll talk about three things. The first one is the Edge AI computing. It's our core business and foundation, and we are in a global leader position. Second, we'll talk about the WEDA software. It's an in-house design container base of the software for edge developer architecture. Meanwhile, combining the Edge AI with WEDA together, we can realize the physical AI across industry. In addition, I will talk about the ecosystem and partnership to co-create the future business collaboration together. All right, so we have many topics to discuss today, so let's begin my session. Please take a look about our physical AI service industry. You can see from the smart factory, manufacturing, medical equipment, retail, those are all our existing service industry. And also for the new emerging industries, such as the semiconductor equipment, energy, AMR, robotics, etc. So physical AI is moving from the lab to the large scale of the deployment. I will elaborate the detail later. Let's talk about the first focus, our topic for Edge AI, the market. The US market, according to the US market research and report, they say the Edge AI is projected to grow to 196 billion by year 2033 with the 23.8% CAGR. The main driving engine is because of the Edge AI inference provide low latency, enhance the data security, and also the real-time response. And you can see the blue chart. The edge hardware continue to dominate the market size, market share, because of the demand of the AI accelerator. Meanwhile, the software and integration services are also very important. And also the lack of the integration opportunity create a very big challenge regarding for the data security, management, and also the large cost of the large scale of the deployment. So this data show you how the Edge AI big market opportunity for all of us, also the challenge to us. This is the background information for today's topic for your reference. How to drive the AI into our industry? The first layer is a cloud AI. I think everyone we may recall 3 years ago, the ChatGPT suddenly appeared in the market. Right? The generative AI, large language model, everyone has experienced on it every day. I don't need to explain for more detail. Let's focus on the second layer, Edge AI. When the computing power deployed to the field, the Edge AI's low latency, data security, and also real-time response create a great advantage. The data no longer need to return to the cloud. But the truly change the industrial competitive landscape is the third layer, physical AI. You can see there are many our service physical AI industry. We have experienced business case for several years already, like AMR robotics, smart manufacturing, human and AI collaboration in healthcare environment. Right? So how to realize the physical AI that they can start to presenting, reasoning, and take the action is very important to physical AI really can lend in to our industry. I want to take the example for your reference, robotics market, for example, the physical AI robotics solution. Back to about 30 years ago, the robot arm has been implemented in the automation factory. But at that time, the main purpose for the robot arm is to reduce the labor cost and also enhance the production efficiency. Gradually, we have AGV, we have AMR, we have service robot in the shop store recently, right? In the retail store and also the restaurant. Industrial drone for smart agriculture and also the humanoid robot, very hot robot industry recently. Okay. So there are many diversified robot applications in the market. So how to support our customer and partner to create an easy solution, support our customer develop their robot application. That's the reason Advantech we provide, we call the physical AI robotics building blocks. You see the left-hand side, right-hand side is a building block. The core is the Edge AI solution. It's a brand for autonomous robot system. Okay? It's handling speech recognition, language modeling, digital twin, and also present the real-time sensing, decision-making, and also action. Second, the autonomous robot solution need the module sensing integration. For example, like visual sensor, 2D and 3D camera, internal, external communication module like Wi-Fi, Bluetooth, 5G, path control planning, LiDAR, IMU, and motion control, motor control, etc. Each of the component is very important to integrate together to support our robot application. And the third one is the software. The value-added software, robotic suite, already integrated all silicon partner their robotic SDK. They can incorporate within our robotic suite to provide our customer an easy develop platform for their robotic application. So start from the Edge AI platform, our module and robotic suite is our building blocks to support our customer, our partner, to accelerate the robotic application development. Okay. So this is the real project, real business ongoing. More than 50 project global partner from our global partner. And more robot application is ongoing. So seeing is believing, please visit our booth at Computex. You will see our global partner, their robot application and solution are really in motion. In addition to the robot application, there are more and more application, industrial application are ready to leverage the Edge AI solution. You can see the medical equipment, surgical robot in the healthcare, also the semiconductor equipment. So Edge AI is really transform our industry. Let's back to focus on our core business, Edge AI. You see the diagram in the center? This is a 3-layer of Advantech Edge AI architecture. Start from the Edge AI embedded, Edge AI appliance, and Edge AI server. We are collaborating with mainstream silicon partner to provide a most comprehensive the Edge AI platform to the market. First layer, the Edge AI acceleration module. They can plug in, embed it into any edge computing devices, instantly upgrade the AI computing power. Second layer, Edge AI inference, designed for specific vertical market, retail, medical, healthcare, transportation, etc. Top layer is our Edge AI server, the ground-based on-premise Edge AI server. They can operate it, analyze all the data within enterprise. On top of the 3-layer Edge AI hardware architecture, this is our WEDA, Wise Edge Developer Architecture. This is a container base of the software package, ready to pre-integrate every silicon partner your software Edge AI solution and SDK. So our purpose is to accelerate the Edge AI solution development for the different service industry. This is our goal. Every year, we are collaborating with our silicon partner, mainstream silicon partner, to provide a comprehensive the mainstream silicon platform to the market. So this year highlight the Intel, Panther Lake, Qualcomm, IQ9, IQ10, and also the NVIDIA Fusion Soul. We are confident we can on time deliver all the mainstream silicon partner solution to the market, and we commit to continue to the edge AI edge computing platform innovation. So thank you for all our silicon partner, your support and your effort. Today, we are about to release the WEDA software to the market. WEDA, Wise Edge Developer Architecture, is an agentic AI tool building up the open cloud, neighbor cloud together to support our customer to accelerate your edge AI, physical AI development into your application. You can see the highlight for the product. It's a cross-platform capability, support every silicon partner your solution. Second, support you to accelerate your AI engine development and full life cycle management. So later on, our chief software architect, Richard, will give you a very detailed introduction about the WEDA software solution. All right? So before I end on my session, I want to emphasize the ecosystem. It's also very, very important for ecosystem to building up the edge AI into every industry. So you can see from the silicon partner, module partner, software developer, wireless designer, industrial association, all the different industry ecosystem from smart factory, MR robotics, medical, and smart city. So we'd like to invite every partner, customer to join together to co-create the future edge AI business and realize the physical AI solution to our industry. So that's the end of my section, and thank you for listening. Thank you. And then, let's talk about our second partnership. NVIDIA is a market leader for acceleration computing. Their GPU, their AI chip, have the highest market share in our industry. So this year, our NVIDIA solution, NVIDIA platform Advantech from the edge computing to edge server solution are full built-in the NVIDIA Nemo Cloud solution. Okay, so to demonstrate the realize some industry, for example, like factory, humanoid robot, the solution to really realize the precision, reasoning, and action for the service industry. So today, we are honored to invite the NVIDIA, the Senior Vice President, to join Advantech Doran to give a speech. Please join me in welcoming the Vice President of the Robotics and Edge AI, Mr. Deepu, Talla. Come.
Good afternoon. Thank you, Miller. How are you?
Hi, how are you?
Good.
They say they want to take a picture. Okay, this side. Thank you. Your turn. Thank you.
How many of you watched Jensen's keynote from a couple of hours ago? Thankfully, very few of you, because this presentation would be extremely boring after that. However, the rest of you, please make sure you watch it as quickly as you can, because there's some amazing news, amazing progress in technology and ecosystem that Jensen shared. So, we've been talking about robotics, edge computing for a long time. Why? Very simple, right? Quite simply, the largest opportunity in the history of humanity. Much of the world is physical. 80-90% of the world's GDP is in the physical world. In fact, automation has been existing for over 60 years. But we still haven't cracked the code for bringing autonomous capability into physical AI and robotics. And you can test it in many different ways. You can ask, how many robots, industrial robots, cobots, AMRs, with any sort of autonomous capability, how many are shipping right now annually? You could pick a number, 1 million, 2, whatever. But then you ask yourself, what is really the opportunity that is in front of us? It's billions, if not tens of billions, right? So we are at least 1,000, if not 10,000 times away from making this happen. So the vision has always been there. Personally, for me, the vision's been there since I was born because I was watching Star Wars and Star Trek. Pretty much everything that's supposed to happen is kind of depicted in those movies. So what makes it so tough? Why hasn't it happened yet? And are we about to change the trajectory? Do we have enough things to actually make it happen? I think there's many reasons, but there's 2 reasons fundamentally why autonomous AI in robotics and physical AI hasn't happened, and that we need to solve. Without that, we can't go. Number 1, of course, is accuracy, right? You all probably are using ChatGPT or Claude or Gemini or DeepSeek or whatever it is for your personal use, for recommendation, for summarizing email, for writing email, any of those. The accuracy has, of course, gotten better and better in the last 3 years. But in almost all cases, there's a human in the loop, in this case ourselves, we finish the email. But when it comes to the real world in physical AI, there's not going to be a human in the loop. So the accuracy requirement is extremely high. You can typically measure it in how many nines after 99 point, right? Depending on if it's a self-driving car, it's probably 6 to 8 nines. If it's a surgical robot, you probably want it to be 15 nines. Maybe if it's an AMR, maybe 2 or 3 nines is okay, it depends. But in all cases, the accuracy is so high that until you hit that mark, you can't really make it useful. We still haven't cracked that accuracy code. And you can test it. How many robots are really autonomously shipping in the world today? So that's number 1 problem we have to solve. And number 2, once the robots become reasonably intelligent and accurate enough for specific tasks, you need to make sure that these robots integrate into existing workflows in the real world. For example, if you try to deploy these robots in a factory, manufacturing factory, there are many existing workflows already deployed, right? From what humans do versus what each of the assembly lines do, traditional computer vision, optical inspection. There is factory operating systems. There's many different protocols, PLCs that all exist in the last 30, 40 years. This robot brain or robot brains that are going to come in, they need to play nice and integrate with all of these different systems. And that integration is extremely difficult to write programs for because some of these are like 20, 30 years technologies. So until we solve those 2 things, number 1, accuracy of these AIs. Number 2, easily integrate these AIs into the existing workflows. Physical AI robotics will not take off. Okay, so with that, I'm going to tailor my presentation towards exactly what NVIDIA is doing in helping the whole ecosystem in the industry solve these 2 problems. So for robotics, you guys hear all this cracking or is it just me? I'm going to move off that a little bit. It's pretty noisy there. So what are we doing to solve the accuracy problem? Remember we said that the accuracy requirements are extremely high, 99.9999 and so on and so forth. It turns out robotics need 3 computers. most of the time when we talk about a robot or physical AI, usually our mind always jumps to the destination, which is the robot itself. We're talking about edge computing, we're talking about deployment. But remember, we can't deploy until it's accurate enough. Otherwise, you can't really scale. So the final destination, of course, is the deployment. That's the edge computer. That's the third computer. But before you deploy, you got to test it and make sure it is absolutely safe and accurate enough to be deployed. And testing, the best place to test robots, physical AI, happens to be in simulation because it's faster, safer, and cheaper. Until recently, the sim to real gap, what you simulate versus what happens in the real world, was not close enough. So you couldn't really believe what you simulate, which means it's pretty much useless. Many of you here have been working in the chip industry. Every chip that any one of us tape out is 100% simulated, emulated before we send to the fabrication, right? To the fab. So in that case, we know that whatever we simulate, emulate, before we tape out, absolutely works. So we need that same capability to come to robotics. And of course, robotics is incredibly harder because of the real world physics and a lot of things, the lack of data. So we need a second computer which is to simulate it. And of course, before you simulate it, you have to train the brain, and it's a lot of computes required. So you have to train these, what started with large language models, went into multimodality vision language models, action models, and now in the last few months, we're starting to see that's not sufficient, so you need to actually model the whole environment. You have the world models and world action models and so on and so forth. Incredible research progress happening in all of these. So what do we do at NVIDIA? We build the three computers. Training, number one. Testing and simulation, number two. Runtime deployment, number three. And then we provide the reference workflows, acceleration libraries, reference models, all the reference software to help you in this whole journey. Number one, to generate data. Number two, to train the model. Number three, to test the model, evaluate the policy in simulation. And number four, lastly, you deploy the model. And remember, once you deploy a model and bring robots into the real world, that's not the end of the journey. In fact, I would argue that's the start of the journey, because these robots will be operating for 5, 10, 15, 20, 30 years in the future, right? And these robots will be continuously becoming more and more intelligent and more specialized for those tasks, which means this flywheel of data, train, test, deploy is a continuous life cycle journey. So that's basically what we do at NVIDIA. So the first problem we have is, how do you create an intelligent model that is accurate? Well, before ChatGPT, we all remember, right? It's like, it feels like it's like so long ago, but it's just been like 3.5 years since ChatGPT came about. But before ChatGPT, if you remember, AI existed, right? Since 2012, the AlexNet moment, to 2022, for 10 years, we had AIs deployed primarily in the form of convolution neural networks and transformers and so on. But the AIs were what we call specialist models that were doing one specific job, right? If you're trying to build a car, you'd have many different models, but each model, one model would be doing lane detection, one would be doing sign detection, one would be doing, path planning, and so on and so forth. So same thing was true for robotics. NVIDIA, we started working on solving these robotics problems back in 2013, and we've seen a vibrant ecosystem. There's over 10,000 companies in the world that work with us in many different industries, many different use cases, all trying to make the robots more and more autonomous. We've been making good progress, but we haven't really hit that accuracy mark. And the problem was, of course, when you create a specialist model, it kind of works for that scenario, but the world is mostly unstructured, semi-structured, things keep changing, it's never static. As a result, the models are brittle and they don't work in all the different conditions, and that's why robotics hasn't taken off. So the way to solve that problem is very similar to what ChatGPT did. ChatGPT was that moment that said, instead of building a specific model for weather, one model for finance, one model for reading, one model for so on, for the first time ever, there was a reasonably good enough generalist model that was built, right? ChatGPT was the first time a reasonably general purpose model that was trained on the whole everything, pretty much everything we put on the internet, all sorts of text, right, books, speeches, and so on and so forth. For the first time, a general purpose model came out. And since then, you see how fast we're off to the races. Everybody starts with that starting point, and then you derive specialists from that generalist. Another way to think about it is, like, you can actually hire forget child labor, but you can actually ask your kid to do a task. Let's imagine your kid is 10 years old. They can do some tasks, but you don't hire them into your company. Why? You wait, they're at least typically 21, 22 years old, have an undergraduate degree, because that's when we believe that's a reasonably good enough generalist. And then from then on, once they come into your company, they are going to become more and more specialized for the next 30, 40, 50 years, right? So until you hit that generalist moment, it's very hard to solve these problems. So right now, the whole robotics industry, from the latest, greatest startups to the best researchers in the world to large companies, we are on a quest to build a ChatGPT type of reasonably good enough general purpose model that is accurate enough for certain robotics tasks. We are not there yet. Okay, so what is the number one problem to create that, for us to create that ChatGPT model? Well, in the case of ChatGPT, you can guess what was the number one problem. Compute was the number one problem. But once we had enough compute, that was solved. But in the case of robotics, it's not about training the model. Actually, where do you even get the data to train the model? You can't take YouTube videos and make a good enough industrial robot. You'll probably have a good dancing robot, but it's not going to be really solving precise tasks for the accuracy that you need, right? So how do you solve this problem? Well, you can go and collect lots of real-world data. That's happening right now. There is, people are collecting from teleoperation to imitation learning to seeing general-purpose videos, right? All of those are good things, necessary, but absolutely not sufficient. And it turns out the answer is, again, using AI to take those, whatever real-world data is available, to create many scenarios. And that's where we spend a lot of time right now. Data is the number one problem today until we get the right kind of data. And it turns out it has become, compute is data. So you need a lot of compute. So we have several technologies. Everything is open source, from NVIDIA Cosmos, which is a World Foundation model. And Jensen, by the way, shared a lot of information about Cosmos today. Cosmos 3 was announced. It can basically create many, many different scenarios, leveraging 3D accurate models to create, predict what the motion is going to look like, what the action is going to look like, create the whole surrounding. So Cosmos is one technology. You can also use real-world sensors on your cars or your robots to actually capture the real world and then generate a full synthetic environment, something called NVIDIA NeuRec technology. So we spend a lot of time on that. We spend a lot of time accelerating for teleoperation, collecting real-world data. So that's one of the biggest contributions that's happening now, enabling you to collect lots of data in order to train a reasonably good enough model. Once you have the data, you're going to create a model. That's pre-training. But once you create that model, you're going to deploy it into a specific embodiment that's probably going to specialize in certain tasks. You don't need every robot to do everything possible. You don't need a robot to be the best tennis player, best golf player, best plumber. You don't need that. I mean, that's too expensive and unnecessary. So what will happen is you'll create a good enough general purpose brain, just like us humans, and then each robot brain will become very specialized in a certain task. So that's the number one thing that we do, is help all the roboticists to create great data in order to improve the accuracy of the model. Now let's imagine for a second we've collected real world data, now we've created all the synthetic data, and we have sufficient data to train the model. And let's imagine we had infinite compute to train the model, to generate the data, and we have a model now. How do you have to test it, right? And if you try to test it in the real world, operating on wall clock time with the number of robots that we have, it will take decades, if not centuries, to solve some of these problems. We have to speed it up, orders of magnitude. And it turns out simulation is the answer. And the problem until recently was the sim-to-real gap wasn't good enough. We haven't completely solved it, but for many use cases, it's gotten close enough that we can actually address this, especially for rigid body manipulation. For locomotion navigation, simulation is now good enough to solve the sim-to-real gap. For rigid body manipulation, it's quite close. and for soft bodies and fine-grained dexterous manipulation with new physics engines that we're working on in open source, that's also coming together. So we spend a lot of time in our simulation environment for data generation, environment generation, for policy learning, reinforcement learning-based policies. And then once the model is created, trained, you have to test it in simulation. So we spend a lot of time doing that. So notice I didn't spend a lot of time talking about the third computer, which is ultimately the destination. And the reason I didn't spend a lot of time on that computer today is we can't get there until we solve the robot brain and testing the robot brain. And we are working with literally the whole ecosystem of partners across the world in many different capacities. You got companies that are building robot brains. We got companies that are building full robots. You got companies that are building special purpose hardware. Advantech, of course, is one of our great partners, cutting across commercial robots to industrial robots to all sorts of use cases, specialized computer to provide that robot brain. We're working with literally every company to create simulation environments, right? And then, of course, you need access to lots of compute. And then sensors and actuation and being able to model the sensors and actuation in simulation is essential. Because how do you test the model in simulation if your sensor is not accurate in simulation? How do you test your actuation in simulation if your actuator is not captured in simulation? So this whole new field where physical companies have to also have a digital twin or a digital cousin, whatever you want to say it, equivalent of it in simulation. So we're spending a lot of time on that. And of course, once you have that, then we all know how to solve the IoT problem. We know how to solve the edge computer problem. We know how to solve the runtime problem because we all have been working on PC industry and the phone industry and the car industry, and we know how to deploy all of these edge devices. But we need to solve that accuracy problem. All right. So now let's say we solve the accuracy problem. You got a great robot. It's like this. Let's say you have a job opening in your company. You hired a great engineer. Great. Intelligent engineer, you brought him into the company. But if that engineer doesn't work well with the rest of you, it's completely useless, right? It's counterproductive. That engineer needs to integrate into your company, follow the process, work with everybody else. The same thing is going to be true for factory operations, city operations, manufacturing operations, logistics operations. And it turns out just like a factory has many different workers, many capabilities, the same thing is going to be true with these autonomous robots, right? You will have robots of different capabilities in the future. You'll have humans in there, different embodiments of these robots. You'll have digital AIs. All of them need to be orchestrated and working together. Who's going to orchestrate all of those? Who's going to write the code to integrate all of those? Impossible for a human to do it. Thanks to Agentic AI in the last few months, this is the answer. So when we solve the accuracy problem, thankfully we have agents to make it easy to orchestrate all of these sub-agents together. So with that, Miller, can I call you back on stage to talk about what we can do together to experiment, how can we implement this sort of a system into your, Advantech, of course, manufactures a lot of things. How are you thinking about it?
All right. Yeah, Deepu, thank you. You clearly explained very clear strategy from NVIDIA for physical AI lending to our industry, from robotics, from also leverage the Agentic AI, Nimble Cloud, Agentic AI tool. So yeah, here's the new strategy from NVIDIA for factory operation blueprint, Fox strategy and program. So aligned with Advantech, we also like to propose our idea. Because of Advantech, we also have quite a big space of the manufacturing campus. Talk about our Lincoln campus. This is our Lincoln campus. Contribute more than 40% of our production capacity, right? So by leveraging align with NVIDIA strategy, we would like to install the factory brain idea concept into our factory to upgrade our manufacturing operation. So our product team, product group, ESG product group, Magic and the team, they are working with our factory team together to come out 5 initiatives Okay, you can see from the production, quality, operation enhancement, and also the autonomous robotics, and also energy management. Those 5 initiatives will be developed into our Lincoln campus as a pilot run. So I think it is our very support Advantech to transform our manufacturing operation. And also will be a great demo site to show the NVIDIA and Advantech AI factory brain solution.
Yeah, that's great, Miller. So as you can see, there's many different use cases and applications there, and each of those require autonomous AI, and each of the technology will advance at a different pace. For example, inspection is advancing fairly fast. We can see now with these latest vision language models that the accuracy of and reducing the false positives is taking shape very fast. But as each of these technologies mature differently, however, having a LLM, a factory brain, enables you to, irrespective of how mature each one is, you can add and delete new processes. So that's going to be a significant advantage.
Yeah, sure, absolutely sure. That leverage NVIDIA silicon platform from Jetson Soul, Jetson IGS, and also RTS Pro solution, we can not only building up full range of the Advantech hardware, edge computing, edge server product line. Also, we can practice it, realize it in our own factory. So once it's ready, we welcome you, and also our partner can visit our Lincoln campus again.
Are you promising a demo next time you're here?
Yeah, I will. We'll promise. We'll commit. Our team are working very hard to make it happen. All right?
All right.
Thank you.
Great. Thank you.
Thank you, Deepu. All right. Then, in last session, we are talking about NVIDIA layer solution, from hardware, from edge solution to server solution. We are also talking about the industrial application from robotics and also from the manufacturing factory. So now, let me introduce the next, accelerating the physical AI adoption across the industry. So we have a more important partner, Qualcomm. They are very professional on the mobile chip solution and also automotive chip solution, right? They are now trying to make the intelligent computing everywhere. So on behalf of Advantech, I want to give the Qualcomm leadership team a sincerely gratitude to all Qualcomm leadership team to give us the great support in the past 3 years. Then Advantech, we formally successful launched entire range of the Qualcomm platform, silicon platform to the market. So here we are happy to have Qualcomm senior executive to visit us and give a speech. Please join me in welcoming the EVP and Group GM, Industrial Embedded IoT, Robotics, Mr. Nakul Duggal.
Thank you, Miller.
Welcome. Again, they want to take a picture.
Photo op.
Photo. Thank you. Your turn.
Thank you very much. Good afternoon, ladies and gentlemen. That was a great presentation by Deepu. Fantastic, super exciting times as the physical world and AI intersect. I think this is just the start. Miller and Casey, thank you very much, first of all, for the opportunity to include Qualcomm in your event today. This is the second year that we are presenting in a row, and as Miller mentioned, we obviously have our roots in the mobile business. We've expanded into automotive. And this entire transition towards AI and the physical world intersecting create tremendous amount of opportunity. So I'll speak to you today mostly about how we are approaching this opportunity. And I think we are really at the very beginning of what I think will be a very interesting decade of change in front of us. The rate at which this change is happening is different across every industry, and at the same time, it is the same. Because there isn't really any industry that has gone through true physical transformation. Over the last 20 years, most industries were about capturing information from the edge, sending them to the cloud, but there was not as much of intelligence that was deployed at the edge. So most architectures really remained where intelligence was captured in the IT systems. The OT systems mostly remained focused on data capture. We were big beneficiaries as all of these networks got connected. We've been part and parcel of a lot of the connectivity layer. As you look at all of these various industries, they are very different. They all touch our lives on a day in and day out basis. And they have a tremendous amount of edge presence. If I think about this in the context of what moves the needle for all of our companies, all of our businesses, the amount of content, whether it is semiconductor content, whether it is software content, the amount of change that will happen over the next decade is going to be enormous. And there isn't really any recipe, there isn't really any playbook that is set up because this change, first of all, is very new. Secondly, these kinds of changes don't happen overnight. Things take time. These businesses are risk-averse businesses. These businesses need to be able to see change happen. I think, as was mentioned in the previous presentation, robotics, for example, very interesting space, but accuracy is going to be very important. It is the same across all of these various physical transformations. The approach that we take is a very broad-based approach. We touch many, many different technologies. We are an edge company at heart. We touch many different edge technologies, as you start to see from the bottom of the slide. The rate at which we think about change comes down to how do we actually influence what does it mean for a business to be able to evolve. Now, obviously, AI is one of many different facets of the change that is required. Ultimately, it comes down to scale. Ultimately, it comes down to cost of ownership, the ecosystem that you can create. And so the approach that we have taken, especially as we have looked at the industrial opportunity very broadly, is to really think about every type of connectivity, every type of compute, obviously intelligence included, but start to think about this in the context of enabling end products and being able to add intelligence in them. So I'll give you a sense as to the approach that we have taken as we start to go down that journey. One example, vision intelligence. And I think, if we've started to use terms like vision language action models in a very common, very, rolls of the tongue. These were not things that were known even a couple of years ago. But the concept of a camera being the eyes of everything that we see around us is actually unimaginable. One approach that we have taken over the last 2 years is to really start to think about a chip-to-cloud solution from a camera perspective. We have recently acquired a company here in Taiwan that is part and parcel now of our IP camera solution. And the approach that we have taken is to really enable, at the silicon level, the intelligence to be able to look at what a camera is seeing, extract intelligence, annotate it, create the layers of outcome that you need to from the very end, from the very base of what is possible, and then track it all the way up. We are building video SaaS solutions that allow us to be able to wrap it up into a service. And we can look at this from any architecture. We can look at it from an Edge AI box perspective, an on-prem appliance, and of course, into the cloud. Why would we think of taking an approach like this? Because we believe that if you have to be able to make a change, you actually have to solve for the outcome. You can't just go provide the chip. You can't just go provide the solution. You actually have to be able to get to the end outcome. And we have started to see customers actually deploy this end-to-end. I'll give you some examples of what that looks like. The other acquisition that we made over the last 6 months was Arduino. We have not been a developer-first company in our history. We've mostly been a B2B company. We've focused on problem statements like mobility, more recently automotive. And the approach that we wanted to take, especially with the industrial business, was the innovation is going to come from the ecosystem. The innovation may not necessarily be captured within our customers. It may exist at the periphery of our customers. It may exist within entrepreneurs. And so the approach was to be able to put into the hands of developers very capable technology, very capable ecosystems, and then learn from that ecosystem what is possible. With Arduino, what we've been able to touch is a very wide variety of customers, very wide variety of developer customers that are developing directly on our platforms. And there isn't really any end to the types of applications that are being developed, because the types of models that we're enabling are various types of open source models that come from the ecosystem. And putting these boards in the hands of our developers allows us to be able to learn the rate at which this is moving. Now, what is very interesting about this, as partners like Advantech come in, as you start to develop an idea that is a project, you have to be able to figure out how to commercialize it. And so the approach that we have taken with ecosystems like Advantech are to be able to build a very seamless, and our partnership with Advantech is only about 3 years old, but to build a very seamless connection between how do you get developers to be able to develop on our platform, then convert that development into a system on module, into an SBC that ultimately results in an actual hardware. Now, we are looking at this very broadly, so we don't really differentiate between what type of end device you would like to manufacture, because we will really touch every single possible type of end device. And this is necessary because we want to be able to scale very quickly as this transformation happens. I think the other thing that we realize is that for this to be able to scale, there will not be a one-size-fits-all. For industries to be able to get to the right cost points, to be able to proliferate technology and change broadly, you have to be able to think about total cost of ownership. And this is why partners like Advantech are critical, because they understand the breadth, the fragmentation, the complexity of their business. We've done the same thing with a company we acquired last year by the name of Edge Impulse, which happened to be a partner company of Advantech for a number of years. Now, this is an MLOps platform that allows you to be able to train and tune models. And we have, over the last 6 months, come up with an approach that allows us to be able to do this on-prem. We have a number of our customers that don't wish to send their data to the cloud. They want to be able to keep the data within their premises. And we partnered with Advantech to take our AI 100 product, integrate the Edge Impulse platform on that product, and enable the ability to be able to actually train and fine-tune models online. This allows us to be able to build an end-to-end ecosystem within the premises of our partners where they're trying to bring AI into their ecosystem. This allows them to be able to go do that. And the approach that we take is very vertical focused. So, this is something that we've done in the history of the company, is to embed ourselves very deeply in what are the types of problems that our customers are seeing. Every customer has a very different type of problem statement depending upon the scale at which the approach is from. So for us to be able to take all the edge technologies that we have, find the intersection of connectivity, compute, AI, and then find use cases that customers are trying to solve for is the way that we start to go solve this. So for example, in this case, in the case of energy and utilities, back in our hometown in San Diego, we worked with the local utility agency to be able to solve for problems around, for example, fires during very high wind pattern scenarios. We have high winds during the summer that usually creates challenges in terms of fires, and that requires you to be able to deploy tremendous amount of AI across a very large geography, which is Southern California. These are use cases that have very broad applicability. So we work with them, but we also work with their ecosystem to figure out how does this actually scale across a wide variety of other use cases. We've been working in the Middle East with ADNOC and Aramco to be able to look at how do you bring edge intelligence into their ecosystems, whether this is with drones or the ability to be able to detect risk in the case of a worker being, in some cases, not fully protected, or the ability to be able to monitor drilling operations remotely. I'll share with you what we are doing in the robotics space shortly in this area as well. As you start to look at the use cases, there are a lot of patterns. It really comes down to how do you drive autonomy? How do you drive the ability to be able to predict? How do you drive the ability to be able to detect something that is likely to happen? And these examples, as you start to apply AI, really come down to situational awareness. If you have a high degree of situational awareness in the environments that you're deploying in, you'll be able to come up with solutions, come up with models, come up with the right type of tools to be able to predict what will happen. And that is the approach that we are taking with our products as well as with a number of our partners. Retail is a space that is actually incredible. I like the retail vertical because it is probably the closest to what all of us expect to see change in. I equate retail, hospitality, healthcare. These are all environments that are likely to be changed by AI very quickly because there is certainly a human-facing element to these verticals. There is, of course, an instrumentation element. You will have, you'll have shelf labels, cameras, a wide variety of sensors that will normally be monitored from the cloud. These can now become intelligent at the edge. And of course, a lot of robotics, the ability to be able to add automation for skills that are well-defined. So retail is another area that we spend a lot of time on to be able to figure out how do we actually create blueprints that make sense for retailers to be able to go deploy AI in an aggressive way. As we switch to physical AI, now this is a super interesting space because if you think about the type of AI that has existed, even over the last 20 years, machine learning has been around for a long time. And it really comes down to how do you look at data and how do you drive some level of automation through that data. Now, as you start to look at industries and what type of automation they need, robots are one type of automation, obviously. But there is really the idea of being able to collect data, look at patterns. These patterns usually exist at the edge. And if you can have enough intelligence captured in these patterns and share that intelligence, you can push the intelligence into the operational plane. So we are spending a lot of time trying to figure out what's the best way to go do that. Now, the most complex example of this is to actually automate the job of a human being. So the approach that we take, we're an edge company. This is something that we've done for a long time. We believe one of the big challenges that the industry will run into as you have to scale this is these are going to have to be power efficient. They're going to have to last the whole day in terms of the battery life. They're going to have to communicate with their environment. They're going to have to be supported by a wide variety of embodiments. So they will not be a one-size-fits-all. And this means you have to be able to go at many different aspects. We break this down into System 2, which is the reasoning layer, System 1, which is the layer that is your faster reflex, and then System 0, which is the equivalent of your nervous system, which is your sensory layer. And all of these are going to be required for a robot to essentially be able to do what a human being can do. Now, obviously, there will be a timeline over which this happens. You can already imagine that tasks that require you to inspect can use a vision language model, and those are mostly in your perception layer with some amount of motion, some amount of locomotion in place. And then there are models that you can apply for physical dexterity that require more reflexes, the ability for you to be able to manipulate. But there is also a layer of communication. You have to be able to communicate with the environment around you. As robots start to scale, you will have to have a multi-robot scenario. You will have fleets of robots that will have to share information with each other. Many a times you will deploy robots in environments that don't have any connectivity to the larger world. These will be deployed in far-flung areas where you actually don't want humans to go. So the use cases will get more and more interesting, more and more complex. And for us, this is a systems type use case, things that we have done for a long time, things that are frankly very exciting for us to think very deeply about. And so this allows us to be able to think about every single type of end embodiment. AMRs have been around for a number of years. I think all of us have looked at this technology. As you start to think about moving up the stack towards what does it mean for a robot to be able to move, to be able to sense its surroundings, to be able to be dexterous in the way that it approaches a specific problem statement, to be able to do this in a power envelope that allows the entire system to be very efficient. These are problems that are, in the scheme of things, newer problems because there are many different issues. You have to be able to get the data. You have to be able to build models that are the right types of models. They all have to be able to run on the same embodiment. We expect that over the next 5 years, the industry will go through stages. There'll be a lot of focus on inspection robots. A lot of that is starting to happen. You will start to see robots that will be used for transportation of goods, no different than what we've seen in self-driving cars. Robots will be able to carry equipment from place A to place B. Ultimately, you will start to see dexterity, first maybe with coarse skills, and then over time with fine skills. I agree with Deepu that these don't have to be general purpose. They can be specialized, and they will grow in intelligence over time. But they have to be system-level problems, and you have to be able to solve them to where they get to scale in terms of industry adoption. We've been working with Advantech, and Miller's team has been very gracious. The IQ9 product that we've been working on over the last couple of years has been refactored as a robotic platform, and this is something that allows us to be able to take these general purpose SoCs and apply them into a wide variety of applications. This allows also for us to be able to take the same platform and provide it massive breadth. One of the things that we've done in our roadmap is to make sure that you have very broad applicability for the same platform. So these platforms are capable, of course, of running a lot of AI, a lot of sophisticated camera solutions. They're all built in with safety. They are designed for extreme environments, and that allows us to be able to move very quickly, especially as the market evolves. And we have introduced at Computex just today the IQ10 robotic reference design. This is the latest humanoid scale robotic reference design that we've introduced, and we believe this will actually be able to allow us to drive the next level of scaling as far as robotics applications go. This is a very interesting time because the distance between solving for a humanoid type application versus solving for something that is slightly before it, whether it's an ARM, whether it's an AMR, that distance really comes down to the amount of AI that you're trying to run concurrently. So with the IQ8, the IQ9, and the IQ10, we essentially have a family of products that allows you to be able to drive to that scale and focus on the ability to be able to scale this as quickly as possible. And finally, a big thank you to the Advantech team for being such a fantastic partner. I think we've really enjoyed the success that we've had with you, and I think the roadmap keeps evolving and expanding. So again, thank you very much, and thank you for your time.
Thank you, Nakul, and thank you, Miller and Deepu, for those insightful perspectives. Thank you. As we've heard, the future of Edge AI is not just about technology. It's about partnership, collaboration, and building a strong ecosystem together. Today, physical AI is becoming a reality across industries. It takes collaboration across the entire ecosystem, from silicon and software to platforms and real-world deployment. Now let's move on to our panel discussion. Accelerating Edge AI, build faster, deploy smarter with the WISE platform and ecosystem. Please join me in welcoming our distinguished panelists to the stage. Let's welcome Dr. Richard Huang, Chief Software Architect at Advantech, and Umang, Managing Director at Nagaro, and Dr. Doran, Vice President of Strategy at Edge AI Foundation. Thank you for being here. Please take your seat. And now, I'll hand it over to Richard.
Thank you. Good afternoon, everyone. Thanks for joining us. I'm Dr. Richard Huang, your moderator for this session. And today, on this topic, we will focus on two major ideas. The first is Edge AI, and the second is WISE. We've known that Edge AI has been dominating the high-tech conversation since around 2023. But what is it exactly? And how does it connect to Advantech WISE? Actually, Advantech WISE has been, maybe most of you have known, and especially for our partner, Advantech WISE has been evolving around 10 years. It focused on industrial AI solution, especially for edge, especially for cloud and on-premise system. But with the growing of powerful GPU and NPU, bring the intelligence to the edge, WISE has to be evolving. So the evolution will focus on 4 key technology, including the digital twins, software-defined automation, robotics and control, and domain AI agent. WISE are going to bring them all together and give us an unprecedented opportunity for applying across industries. So in this session, I will bring Dr. Ed, who is at Edge AI Foundation, and also the expert in applied AI. And Mr. Umang at Nakul is a managing director of AIoT Solutions. Please give a warm welcome to Dr. Ed and Mr. Umang.
Thank you so much.
Thank you.
Okay. So let us reveal the secret of the Edge AI. The first question I want to pass to Dr. Ed. Give your AI background. Could you explain Edge AI in plain English and why it's becoming so important to industry?
Well, great. Thank you so much, Richard. I appreciate the question, and thank you to our hosts for inviting us today. It's an honor to share this stage with such distinguished people, both before us and will follow us later today. We've talked a bit about Edge AI already today, but maybe it's helpful to make it real for a minute. When we think about Edge AI, we're talking about building on all of the advances that we've built over the last few years in the hyperscalers. All of those advances that were happening in that centralized intelligence area, but then extending them out into the real world. So that can be what we call the on-premise instances, not just those great on-prem instances within the factory that make sure production runs well, but also they're the shipping container, packed with intelligence sitting outside a mine in the outback of Australia. They're deep in the ocean in the form of a submarine that's cruising along underneath the waves. On-prem has incredible diversity in it based on the capabilities, the needs, and the constraints of the scenario. It's also the vehicles, whether those vehicles are moving through the ocean, along the surface of the Earth, through the air, or even screaming above our heads right now in low Earth orbit. It's the smart devices that are in your pockets right now or at the tips of your fingertips. Yeah, I see some of you texting. I see that. These are all Edge AI, even out to the intelligent sensors that get deployed out in the world to do things like track endangered species, warn of floods, warn of wildfires, warn about mass wastage or landslides. So when you look at it from the value generation lens, Edge AI has a vast ecosystem of devices and scenarios that takes that intelligence that we built in the data centers and brings them out into the real world. And that's both what drives its evolution and adoption, but also makes it challenging to do, because it's really hard to do Edge AI in that shipping container. It's really crucial to do Edge AI well in that vehicle that's speeding down the road. It's really vital to do Edge AI well in the surgical suite. And so this is why this is so exciting and such a great opportunity for us, because it allows us to draw value from a type of AI that's going to be function with very limited bandwidth, that's going to sip energy and not use much of it so it lasts a really long time, that's still going to have lightning fast latency, that's going to maintain our privacy by keeping data and intelligence close, or even protect some of our security by creating a much smaller attack surface to go after. So I find Edge AI incredibly inspiring, not just for the technical bits that we've been talking about today, but the value it drives in the real world.
Thank you, Dr. Ed. It's clear that according to Dr. Ed's explanation, we can understand that Edge AI is not just a concept, it's a reality. So the next question, I will pass to Mr. Umang, who is very full experience in practical IoT and AI, especially for industry. So the question is, from your Nagaro experience, why is AGIO so hard to scale alone? And why do so many promising pilot projects fail to reach end production?
Yeah, thank you, Richard. Greetings to everybody. I think we saw earlier through Miller, Deepu, and Nakul, the amazing technology that is being launched. Our role as Nagaro is to bring that technology to our clients and deploy them with their products in the field, in their warehouses, in factories, and so forth. So we are sort of bringing that technology into that use case. And both through Edge IoT and now through Edge AI, we recognize that there are not 1, 2, or 3 reasons, but there could be more than 60 reasons why a pilot may or may not succeed and may or may not scale. What you see on the slide are just about 30-odd reasons. So you have to think about your roadmap, why you should have a certain class of use cases when you are deploying Edge AI. How does it help in your business goals? You have to think a little bit about the use case that you have chosen, how that use case, ROI, feasibility, reliability, scalability happens. And then very importantly, you have to think about what's your solution strategy. In that solution strategy, what role does software have? Do you build your own software and spend 6 months doing it? Do you take something out of the box which can't be customized? Or do you use accelerators which can be customized to your requirement? What about hardware? We saw some fantastic hardware inspirations over the last 1 hour. So how do you select that fantastic hardware? What type of parameters do you need? How does it help in your scalability from that successful pilot to a global rollout across your warehouses, factories, logistics centers? The partnership ecosystem plays a very, very big role. You know, we are here thanks to our wonderful partnership with Advantech. And last but not least, enterprise integration. A pilot can have a narrow set of requirements over which you are showing the success. Enterprise integration is what is required when you start to scale. We are today doing use cases around Edge AI in more than 20 countries, more than 50 such projects. And this is just 30 of the things that we think about among the 60 that are there. And maybe on the next slide, what I can show is as an example that where with a chemical company, which is our client in United States, how we brought robotics on a packaging line and implemented Edge AI, Edge IoT solution, bringing both telemetry data as well as visual data from the robot on the packaging line. Both these data were brought in a way that supervisors, etc., in remote parts of the factory or in central factory could look at what's happening on the packaging line and, of course, not get exposed to those hazardous chemicals. So in a sense, Richard, we have to think very carefully about what solutions we are trying to build and how we are building.
Thank you, Mr. Umang, and give us very practical opinion. And but it leaves us a question: where do we go from here? That means what's the next step? So I will turn back to Dr. Ed. Since we can't become Edge AI expert overnight, so where should industrial companies draw the line, especially for our partners? What do they truly need to own, and which parts of the stack are better handled by partners, just like Advantech, rather than built from scratch?
Oh, thank you. That's a great question. So I look at the presentations we saw this morning, and we saw some really interesting and frankly incredible advances. If I look around this room, I know there's more coming. So we will continue to see, and I see this every day at the foundation, people pushing the state of the art for the design of the hardware, and I can see some of the hardware folks here. We'll have people doing new work on the software layer and the intelligence layer in the form of new sensor fusion, new types of models, new approach to building intelligence. I'm seeing greater advances in orchestration, deployment, management. All of these areas are going to continue to evolve at an incredible pace because there's so much demand, there's so much data, and there's so much value to be delivered. So when you're in that moment, when everything is changing that quickly and every change catalyzes the next evolution, maybe the biggest question, and this might be a little controversial, is just to ask, what's not changing? What isn't changing as we go up this step function of AI? And what hasn't changed for each of us is you know your domain. You know that you will deliver the next generation of hardware. You know you will deliver that sensor fusion. You know you'll deliver that model. You know you'll deliver that orchestration step. And you know your customers. You know your partners better than anyone else. So build from that strength. Build from that deep knowledge of the scenario and then partner strategically to bring other best-in-class players into your orbit. So what you're doing is building an ecosystem of the best possible solutions, but the benchmark to do so is defined by that value you're delivering to the customer. So if you're trying to put intelligence in a submarine, you understand what that challenge looks like. If you're bringing intelligence and putting it in a mine way out in the middle of nowhere, you know the criticality of those decisions to protect human life and still run an effective business. If you know that you're going to be doing work in hospitals, how vital it is to give the right diagnosis and protect privacy at the same time. So the best opportunity for you is to get very crisp on where I'm going to lead the world and be best in class, and then how do I find the right partners to give me the absolute best in class services to complement my knowledge and allow me to build from that unique perspective on the world.
Thank you, Dr. Ed. Following the Dr. Ed's answer, that means Advantech should provide a solid solution that help our partner, and help our partner to focus on the domain application, but not the riverbed, the infrastructure. So let me explain. We are going to provide the WEDA, Wise Edge Developer Architecture, also that Miller has mentioned in his presentation. Why do we promote the WEDA at this time? What is it? WEDA is one architecture for all. What does it mean? We know to develop an Edge AI solution, it needs a lot of features, including the data management, device management, and AI lifecycle management. We have put everything in it. It will help our partner to reduce their development time and cost by up to 80%. But it sounds still very abstract, right? And because that is for developers, I believe most of people still can't understand it. Just like NVIDIA CUDA. May I ask what is CUDA? Everyone knows its name, but I believe only few people really understand it. So for our partner, I think the only thing you have to remember is to build Edge AI solution. WEDA is all you need. That's the slogan. Okay. So, but we still have to take a closer look at what WEDA it is. Allow me to stand up and elaborate this part. To build an Edge AI solution, usually we need two parts, the edge part and the cloud parts. And just like Miller mentioned, we have a lot of challenges you have to solve when you build an Edge AI solution at the edge part. The first thing is cross-platform problems. Advantech has a lot of silicon partners. We have a bunch of hundreds of thousands of edge devices. the silicon include AMD, Intel, Qualcomm, NXP, NVIDIA, even Rockchip. But if you want to develop application on top of it, how do you solve the migration problem? Maybe you develop application on desktop computer that is NVIDIA chipset, but how do you migrate to Qualcomm? So for us, we provide so-called ready-to-develop containers. We publish that, we build a Advantech container catalog, and we put a lot of those tested containers on it. It's not just a cross-platform. We also build a lot of AI boilerplates on it, such as if you want to build a post-detection, large language model, or object detection. Everything has been on it. You don't have to worry about the cross-platform problem and the environment setting. And even another problem is when you run, we know in the future, every application on the edge, we will deploy as a container. But how do you pass through the Docker engine to access those resources on the host, such as a peripheral or different GPU and NPUs? So we have done all of that. You just use it. That's the first thing. And the second thing is, how do you control the peripherals to link the robotics? We also integrate the rows to nodes and prepare as a bridge so that you can access the robotics very easily. We also implement the digital twin protocols. Why do we have to do this? Because the tradition OT communications usually focus on numeric data, but we know that in the future, especially for the Edge AI, and those data have to be analyzed or processed in the cloud and the edge at the same time. It's not numeric only. It's image, it's binary, it's data pack. So we implement the digital twin protocol. All those data types can be consumed, not just at the edge, but also at the cloud. And the cloud part, the Edge AI, another challenge is how do you manage those devices? And how do you onboard those devices? So the zero-touch onboard and fleet management, orchestration, even the AI model lifecycle management, out-of-band support, everything has been it. And moreover, I'm not sure if you noticed that there is a WEDA code agent that's based on NeMo Crawl. That's NVIDIA NeMo Crawl. What is that? I believe some of you have read the news. By 2030, 80% of computer code will be generated by AI. So in the future, if you want to build an AI agent, no matter on edge or in the cloud, you can use our WEDA code agent to generate dashboard or the autonomous AI at the edge. Let me give a demonstration. We want to give an AMR example. We use a WEDA code agent to tap into the connected sensors, such as the 3D camera, LiDAR, and G sensor. We just ask the WEDA agent to build a dashboard and display the real-time readings on straightforward dashboard, just like that, this one. Okay, and if we want to give more capability to these AMR edge devices, we just spin up another container. And we capture the image streaming from the connected camera and use a vision language model, a VLM, to interpret the image they receive to understand the agent it sees. In this demonstration, it just detects the falling box blocked the aisle. But in the real world, we are not just manage 10 devices. We may have to manage thousands devices that scatter around the world. What should we do? So the WEDA code agent, we can just ask it to deploy and manage those devices directly, just give a simple prompt. And the most beauty about it, you can ask it to build a dashboard that manage all the devices. Okay, we can see it's coming. Okay, in this case, we can see there are 10 devices that are being monitored just by giving a prompt and create a dashboard. Okay, so it's quite, that's an overview, that's a very simple view of the WEDA. But next, you may ask, does it work in real world? So let me back to Mr. Umang. I have a question for you. According to your experience, how do you create a real world use case for what is the process to run an Edge AI solution?
Yeah, thank you. I think the example that I narrated very briefly a few minutes back was an example from a chemical factory. I'll switch over to an example from a machine manufacturer to take your point, Richard. So this particular client has been for 100 years in the industry. Today they have about 250 different types of machines which they manufacture. A machine that they deploy in the field can have a lifetime of about 25 to 30 years. So obviously, the machines that they're deployed and made in the early part of the century or in the last 10 years, they do not necessarily have all the abilities or sensorization to pull data, to be able to, for them to monitor those machines effectively. So when those machines go down, they have to fly in engineers in different parts of the world to fix the problem. So what we went about with them is to, through a very playbook-oriented journey, which had more than 50 steps. So I'm just showing a few of them on the slide that you see. It started with the business goal of how do you take, the original objective of what you want to do. And from there, we started to understand what was there as this type of a problem, looked at what should be the solution strategy, what should be the transformation roadmap, and within the solution strategy, identified the software strategy, the edge strategy, the hardware strategy, the cloud strategy. In some cases, everything could run on cloud. In some cases, everything had to run on edge. In some cases, we could run some things on cloud and some things on edge because of various connectivity issues. And when you have done this, it's also important to then select which machines we would start with when we start to do these pilots and then we scale. So we took some of the products which are their most best-selling products, some products which are also some of their more recent products where they have high sensorization, went through a development process which itself used AI for code development, just the way you said. So what we would have typically developed in 6 months happened in about a month and a half. So an order of shift of 4 times in the development cycle. And it was done iteratively in a way that by the time we were hitting into the 6th week, the customer had a solution that they could start testing. Now, what the solution did was to pull data out from machines which were earlier not so capable of providing that real-time data. In the parallel, we started to provide them also a parallel stream of predictive analytics. Remember the original problem? My machine breaks down and I have to send people to different parts of the world to fix it. So predictive analytics, fully running on the edge device, aided by bringing transparency from the machine, visibility from the machine, help create 2 different streams of pilots which sort of converge together. What's the outcome for such a solution? Today, they have this solution rolled out for 11 different types of machines across 200 customers. And of course, this is a little bit of a start of a journey, so many more steps to go. But back to your question, I think it's very important from our perspective that we look at this exercise of bringing technology to the customers, focused on the use case and bringing that consultative thought process that ultimately we understand the domain of the customer and their final pain point in need.
Hello. Thank you, Mr. Umang. That's a strong example that how to realize the industrial Edge AI solution. So the one final question, Dr. Ed. There is a growing talk that AI agent could reshape industrial software. We will focus on this question is about AI agent, even replace systems like SCADA, MES, and SAS. How do you see this debate? And when should organizations start introducing AI agent to edge and data center?
Hello. It's an interesting question because you have these conversations around intelligence and these intelligence around action, conversations around action, but let's just go to reality. Think about, have you ever had a coworker who was incredibly good at thinking but never took any action? How much value did that create? And then the converse, how many of you have ever had a coworker who would act without thinking at all? Not really a value generation conversation, more a risk mitigation discussion. Action and intelligence have to go hand in hand. And so too in this case. So we're building all of these incredible capabilities, fuse across different sensors, to see things that the human eye cannot see, to sense vibration in machines for predictive maintenance that we couldn't possibly do, to do wildly complex logistics that no human being could do in the same time frame, to make critical decisions accurately and an inhuman scale. So taking that intelligence and turning it into action means Edge AI will drive the evolution of agents. By the same token, the actions those agents take, the outcomes that they have, will in turn drive the next generation of Edge AI. So Edge AI will be the reason that you can move a vehicle across the ground and still have it make safe decisions even with the loss of connectivity. It's the reason you can give healthcare support in critical scenarios without compromising patient privacy. It's the reason that you can have extremely robust solutions even under environmental conditions that would shut everything else down. So it's not a question of are we going to continue to have the evolution of Edge AI or are we going to drive the intelligence of agents? They're going to go hand in hand. Agents will give us new opportunities to create value. They will also give us new opportunities to drive back the evolution of our intelligence infrastructure. So I think I would challenge us to think about how do we take this intelligence that we built on the edge and express it through agents? How do we learn from that experience? And then how do we use that to invest in the future together? This is back to the partnerships we talked about before. Who's best in class for building the components of your Edge AI? How do you bring them together to take intelligent actions? And then how do you use that to catalyze a movement into the future? This is our opportunity. The thing that also doesn't change is your best chance to have the future you want is to build it. So that's our challenge coming out of today. Let's build the future we want together, intelligent and actionable.
Okay, thank you, Dr. Ed. It sounds like bringing the AI agent to industry is inevitable, but the challenge is how to build a stable, reliable AI agent. So for this part, the WISE team, Advantech WISE, based on the WEDA and IoT suite, we built an AI agent runtime. Of course, that is also based on NemoCrawl, that is more secure and stable. But to build a reliable and practical AI agent, actually it's not easy. You still have to put a lot of effort on it. To help our partners, so we provide so-called the foundation skills and, sorry, I cannot say it. Foundation skills and the domain skills. That's for different domains, such as the manufacturing, the energy, the retail, healthcare. So our partner, when they try to build the AI agent, they don't have to start from scratch. They just on top of our foundations to build the domain AI agent they need. Okay. So before we wrap up, I would like to announce the partner program, especially for the development. The partner program is a little different from the partner that Miller just mentioned. For Advantech, we have two types of partners. One is to help us to complete our product. And another partner is to realize the Edge AI by using our product. So the partner program is for development. Usually, the partner that use our product to realize the Edge AI can be categorized 3 different types. The first one is individual developers and researchers. We provide free SaaS cloud, so you can use that for POC or small business. And the second is AI startups and ISVs. We provide a design-in and co-creation program for this type of partner. Usually they put WISE or WEDA in their product. And the last one is system integrators. They use our product as in their project to speed up their completion of project. And this type of partner, usually they deploy their solution on-premise, so we provide software and hardware bundle solution. Okay, that's our today's session, and I hope you found this session insightful. Thanks for attention, and Dr. Ed and Mr. Umang. Thank you.
Thank you.
Thank you very much.
Thank you. Thank you to our distinguished panelists for those insightful perspectives. Thank you, and please return to your seat. Thank you. Now, as we prepare to close out the first half of our program, we have reached a very special highlight of the day. We are deeply honored to welcome back a visionary leader who has been at the forefront of this industry for decades, who will be sharing a keynote titled Edge Computing and the AI-Powered WISE Solution. Ladies and gentlemen, let's welcome the chairman and the CEO of Advantech, Cassie Liu.
Hello. Dear Advantech partners, very nice to meet everybody. Earlier this year, Jensen Huang, CEO of NVIDIA, made a statement. AI is a 5-layer cake. Okay, I think everybody now already familiar with that. Okay, let's overview this 5 layers. Okay, layer 1 is energy, electricity supply. Layer 2, chips, including CPU, GPU, and memory. Layer 3 is infrastructure with data center, computing facility. Layer 4 is large language model for AI services. Then comes layer 5, applications. The application is mostly on-site at the edge, including area like industrial AI solution, robotics and automation, enterprise AI agent, and the smart factory, and more. Okay. From Advantech point, we like to commit to focus and devote on Layer 5 in the next several years, next many years. So that's the reason why I put Advantech on level 5. That means Advantech, and hopefully also our partner, will contribute to the level 5 of AI. Advantech's corporate direction and focus is edge computing and AI-powered wide solutions. That means Advantech try to become the leading platform company for edge computing and related. And in Advantech, we have 4 major business groups, including embedded edge AI and robotic platform. Number 2, industrial automation and intelligent systems. Number 3, healthcare and smart city services. And plus, WISE and CUDA. Sorry, WISE and WEDA software group. Okay. Those groups are all for level 5. They're level 5 of the AI cake. Okay, sorry. I wish to use this picture to explain the details of our software group. The WISE plus WEDA group. Advantech WISE carry the mission to be the industrial edge AI agent enabler. Many industrial domain AI agents will be available with like Lima Cloud, Open Cloud. This is a breakthrough technology just happened recently. I believe that the Lima Cloud will bring a big breakthrough, because before it's difficult to bring AI to the real application of edge. Okay, and this is, I repeat this slide of Richard, and it's about the WEDA. And I just want to explain a clear message. WEDA will be bundled with most of Advantech hardware free of charge to our customers. So WISE, we will charge the the minor and membership charge to customer, but WEDA will be free to all the developers. Advantech wish to build up the domain AI agent solution partner ecosystem. This is a quite big ecosystem. Start from the bottom. You know that Advantech offer a rich portfolio of a hardware device. And after the device, come up to Advantech WISE and WEDA software tool. Okay, hopefully solution integrator can integrate hardware and software and the application with easy going effort. Okay, Then comes the AI agent solution for different industry domains, like smart factory, energy and utility, transportation and logistics, smart city and building, retail and hospitality, plus healthcare. Okay, a lot of applications. All domain AI agent can be deployed to worldwide market after some time. Okay. I'll come here first. I want to use smart energy as a typical example of ecosystem. There will be, for the energy side, there will be edge servers. We still need a server at the edge to host all the software. So there will be a server at site connecting to cloud and large language model, also covering like Lima Cloud, Open Cloud, and other Edge AI platform and functions. Then we will add Advantech developed iEnergy domain function modules plus iEnergy industrial skills. At the edge, iEnergy system will be extended to sensors and actuators to create physical world monitoring and autonomous operation functions. So I just want to show, explain how the ecosystem will become. Sorry. Okay, I want to talk about the SI partner program. Advantech need to work together with worldwide SI partners in order to customize and deploy the system to customer side. It still needs a lot of effort. So this is how layer 5 of AI cake, okay, the application layer will be built up and grow in the future. Advantech need to recruit, work together, and empower the SI partner to realize the domain application layer at site. This is how we plan to long-term implement that kind of ecosystem, hardware, software, and worldwide SI together. Okay, this is my last page. In the coming AI era, I believe everybody understands that the AI era is coming to us. AI technology is changing the world to a new stage of intelligence. A new future is ahead of us. Advantech plus wide software plus AI agents plus our partners, we can create a limitless future together. Let's build the next industrial revolution. That's the end of my presentation. Thank you very much.
Thank you to Casey for those wonderful sharing. Thank you. And please return to your seat. Thank you. Through today's session, we've again wonderful insights into how Advantech is driving innovations with Edge AI and Physical AI and WI solutions. Now we are going to take a break for about 25 minutes. Our second session will begin at 1:45. Please come back at that time. Thank you. And live refreshments are available just outside. Please enjoy. And don't forget to take the opportunities to connect with fellow attendees. Thank you for your cooperation. We'll see you later. AI-powered intelligent machines in the real world. Please join me in welcoming our distinguished panelists to the stage. Let's welcome Ms. Linda Tsai, President of the Intelligent Systems Sector and the COO at Advantech. And let's welcome Ludovico Marenzi, Physical AI Segment Sales Manager, Asia Pacific from NVIDIA, and Dr. Shintaro Iwamura-san, Distinguished Specialist of Technology from Umang Corporation. Thank you for being here. And now I'll hand it over to Linda.
Okay. Thank you, everyone. Good afternoon. We are very happy to have the panel discussion today, talk about how intelligent machine can happen in the real world. And we know that we talk about AI many times today, especially physical AI. And so this panel discussion, we are discussing that how AI is no longer confined in the car or software. It happened to the real world, to machine. So I'm very happy, I'm very delighted to have two distinguished guests, Ludo from NVIDIA and Dr. Iwamura from Umang Corporation. Thank you for your coming. Yeah. So the next 30 minutes, we are going to share that how from a point of view, from the technology, like AI as accelerator and the software, and Umang Corporation from the OT side, how can they implement that all the AI technology together as an equal partnership on the OT environment? So start from the big picture. People think about something fundamentally changed over the past 18 months for AI. AI changed a lot. So for Ludo, one question for you is that how is the customer now with NVIDIA platform that they are not able to do what you can provide from NVIDIA platform, what they can do that was not able like 12 or 18 months ago? And the second is that what is the visible change you are seeing in the past month?
Well, firstly, I'd like to profoundly thank Advantech for inviting NVIDIA. We are humbled and excited to continue to grow our valuable relationship with you while helping accelerate vital partners such as Umang. Enterprises can now close the loop between digital twins and real-world operations. They can simulate environments, generate accurate synthetic data, train models while deploying them in production within a continuous CI/CD loop. We see the most visible change is moving from standalone computer vision deployments to full operational AI systems that monitor, optimize, and act in real time across an entire workflow. Another major advancement, NVIDIA is deploying autonomous, self-evolving AI agent in production environments with enterprises-grade security. That's something that wasn't possible 12 to 18 months ago. NVIDIA's NemoClaw framework now provides the governance stack, moving AI agents beyond prototypes, which includes immutable logs, role-based access controls, combined with fleet orchestration. Customers can now deploy multi-agent systems by simply defining skills instead of building complex systems from the ground up. Skills are reusable capabilities. Examples include analyzing data, generating reports, or taking actions. this can now be easily shared across multiple agents.
Right, thank you, Ludo. So you know that when we talk about that time, we talk about that month and year, about AI evolution, is something like the speed as the light. So we hear so many technology from NVIDIA. But down to the earth is that how do they implement in OT? So Dr. Iwamura, that from intelligent machine and factory operation, what have you seen and the change in the past month?
Next slide. Yeah, so the left side, generative AI adoption, I think it was emphasized in these sessions. So everybody knows between 2022 and now there's a big difference. And before 2002, many people feeling, when I ask to the customer, they say, how to use the AI, what is AI? Especially in the manufacturing, as you can see in the right side, in the IT world or knowledge management, they are using many AIs, but in the reality, in the factory floor, only 10% of the adaptation is happening in the last year. That is a reason, because the IT world, the information technology, there are so many data on the web, but in the operation data, there's many secrets, and it is impossible to run in the AI. And also, the meaning of the data is not inherited from the data to the IT world. That is a problem, yeah. So between the 2022 and now the changes, previously, they are trying to AI as a strategic option, but now, when we visit the customer, they always say, bring us the AI to the factory floor. That is the biggest change.
Right, so not only that what we are talking about today, even from Umang, from OT side, from intelligent machine, and from factory, they are also asked by their customer, how can Umang or other that OT player that they can embed the AI to help our efficiency? So from a Advantech perspective, even though today we talk about intelligent machine and factory floor, but from working with our eco-partner together with software ISV or so many respectable technology leaders, we actually seeing AI is bring into the many industry. Of course, today we focus on factory. But again, I have to say, OT integration still remain a big challenge for everyone. Because that is not just that you need the edge platform, you need a lot of good quality data. But what Advantech doing now is that in order to minimize the gap and help our customer integrate the AI into a scalable edge AI platform, and we will partnership with NVIDIA to develop a different platform, not just on the AI accelerator, and with the domain we have, we integrate lots of I/O and field bus and connectivity to help our customer, no matter use on intelligent machine or on other application level. So next, I'm going to the bigger question is that, how do we do implementation? So Ludo, from the implementation, why I know NVIDIA have a lot of good technology, and also that what are the customer benefit from that? Also on the Omniverse, what are you seeing that what can help them like they are not able to do before, but with the Omniverse and digital twin, help them to implement physical AI in the intelligent machine?
Well, synthetic data shifts industrial AI from a limited data scarce process to one of massive data availability. Instead of relying on very expensive and slow real-world data collection, customers can quickly generate huge amounts of perfectly labeled data while also simulating rare edge case scenarios. This enables faster training cycles, better model performance, and scalable deployment across complex environments that were previously impossible to support in the past. NVIDIA is now optimizing the entire physical AI stack for agents by making our libraries, models, and framework agent-ready. This includes our Omniverse libraries for simulation and digital twin, Cosmos World Foundation models for physical world reasoning and synthetic data generation, Isaac for robot simulation and robot learning, Metropolis for vision AI, Alpamayo for autonomous driving, and of course the Jetson platform for edge AI development.
Right. I would say that next to AI, the big buzzword is actually data. So simulation, synthetic data is really accelerate a lot of physical AI into OT world. So back to the OT side, so Dr. Iwamura is that I know Umang have like generate a huge amount of quality data from X-ray and from AI machine. How does AI use those data in the factory floor?
Yeah, first of all, we have selling the AXI. It's a X-ray, 3D X-ray inspection machine, and the AOI is optical inspection machines. And the AOI and the XI is we are trying to achieve the very difficult problems. Yeah, today I'd like to explain about the example of the HBM, high bandwidth memory. HBM is made of the DRAM, and it overlaid the several layers, and each layer has a through-hole. It's called the TSB or TGB, through silicon beer or through glass beer. Yeah, this, as you can see in the picture, the size of the beer is very small. So when we use this AXI, even in expert, it's really difficult to judge this is a fail or true. So, and also, if you see the AOI, the component placement difference can judge. That also, if the size of the circuit boards make it smaller, it is really difficult to judge. To overcome this, can you go to the next slide? I was collaborated with the NVIDIA's Cosmos team. Yeah, and this is the first time we achieved this in the first time in the world. And today is the first time show in the public also. Yeah. To achieve the reasoning, this XI data, it requires to the annotation of the circuit board. As you can see, on the solder, there's a PCB and there's a solder. And as you can see in the color, why I'm putting a color is HBM in the real production line has a warpage problem. Because of the coefficient of the thermal expansion difference between the silicon and the copper, the difference is a 6-time difference. So when we add the heat onto the silicon tip and cool it down, the size of the width is different. So it will happen in the warpage in the circuit board. But the difference is very, very tiny. So if we use a BLM into that, it is impossible to understand using the BLM. It has to treat as a color, and also it has to treat with a 3D. That is the key point to overcome this problem. To overcome this problem, I introduced the multiple LMM and also the BLM, and also using the 3D annotation to that. So I'm using these kind of multiple collaboration of AI agents. Now I could achieve the reasoning of this problem. Like this problem, there's a warpage on the circuit board. As you can see, it can make the reasoning. And after that, you can ask the questions. And also, it can refocusing onto the problem point also. Yeah. That is the difficulty. The important point is how to add the meaning of the physical data to the AI. That's the point of this. Yeah.
So is that remarkable example from Umang is that this is exactly how use AI into the AOI XI machine. So actually, before the panel discussion, I had the chat with Dr. Iwamura on that. I cannot say that because you say it's the world first. So and you haven't published it on the Umang PR yet. Maybe we can say today is that journey on VLM. Everyone know about VLM, video language model, and journey is for 2D. But Umang is world first to use VLM with a mix of AOI and XI. So with that, it's really like, it's not like using 2D because right now we know all the optical inspection is 3D. So combined with VLM. And most important is that that's happening at the edge. which means that anything happening at the edge is related to the Advantech, right? Yeah. So, yeah. So I'm going to circle back to that the three computer framework from NVIDIA. Of course, everything landing is at the edge, but before at the edge, we need to do the simulation, we need to do the training, and with the Omniverse, with the digital twin. So with three computer framework, I think it's very important is that not just only robotics, even for machine simulation, you can do a lot of simulation, edge computer or server, Advantech server, Advantech workstation to running at night before we implement into the field. And this become the close continual workflow. And that is not an isolated system. It's more like from sim to real or real to sim, and how can we learn and improve? So the next question, again, I have the 4 questions for each of them. So the third question will be that after implementation, I'm sure we faced some of the challenges in the past. So Dr. Iwamura-san, can you share with us what are the difficulties that you face when you do the implementation? Especially we want to implement across different machine and different factory.
So there's a 3 steps to achieve that. First is, as I mentioned, assigning the physical data to the meaning. That was a so difficult thing because one solder to detect that, it has to set to the like a few hundred of the parameter. Yeah, and when you go to the manufacturing and the real process, when the failure will happen, yeah, because when we set to the failure, normally we have a margin, means a positive failure, and after that, when we fail the production line, it goes to the professional, and the professional will judge it is fail or not. Yeah, but when we that, the circuit, AI circuit was very expensive. So it means you have to judge very carefully. Even one failure is quite expensive. So that is the first step. And the next step is the IT-OT integration. This is, I mentioned, I assigned the meaning to the OT physical data. The next step is connect to the IT. So I collaborated with the Cosmos. It can make the reasoning, and means that it can read a human. That is the second step. And the third step is the human readiness. Even make the reasoning, if there's an operator or designer, their expert knowledge is different, means it has to be set as each person, and also it has to ready for like in designer case, that has to be reason more detail. If it's an operator, it has to judge the failure or true. That is the most important thing for the customer. So after finish these kind of 3 steps, now it can adapt AI to the real operation world. Yeah.
Right. Thank you for sharing. Indeed, it's not that AI isn't just overnight, that after the data training, simulation, and you can do inference immediately, especially even though we implement AI, still some of the people that we need to over there on the factory floor. And the second question to Ludo is that what do you see from the platform perspective? What are the challenges?
Look, the biggest friction points is integration into existing systems and processes. Industrial environments often have fragmented and proprietary data sources, legacy infrastructure, and established inflexible workflows that have been difficult to address. There are also gaps between simulated environments and real-world variability, as well as the need to align AI systems with human operators and physical processes. The challenge is making AI fit naturally into production, not just proving that it works.
I see. Okay. So again, you know, we have different role, right? From the OT, from the platform, also from the AI technology. Advantech provide a scalable AI platform. And what do we see from our view of the challenge is? This is complicated. I might explain that later. So we see is that from different application, they will connect to different machine, and they will connect to different sensor. And then they may have different requirements for real-time latency. So by doing that, I mean, it's difficult to do. When you want to do an AI project, it's very difficult. You do everything from the scratch by yourself. So within Advantech, we are providing the concept we call AI Foundry concept. This is provide 7 core modules. With these 7 core modules, instead of building everything by yourself from the scratch, we hope that we can provide you that standardized building block on the robotics or on heavy machinery, that if you need functional safety, then we have the module for functional safety. If you need the remote measurement, and we have the remote measurement remote measurement module. Last but not least is that all the AI need to connect it to sensing. And we are partnership with that our sensing partner, and to get every integration ready. So with the concept of AI Foundry, with the 7 core module we define, we are hoping to provide you the standard building block that we are working with the global eco-partnership, on the software partnership, also on the sensing partnership, together with NVIDIA. So even though there's a challenge over there, there's a difficulty, and applications so fragmented, this is what we want to provide the building block. To summarize the panel discussion, the last one question wrong, it will be that, what is the future? It's very important, why is the future? Because AI is evolving so quickly. So question to Ludo is that, how do you think the factory in the year of 2030?
Well, I think it's a great question, but we don't see an environment of just simply managing individual robots. Instead, we anticipate singular, giant, self-operating robotic systems, coordinating fleets of humanoids, AMRs, and vision-based agents. This means manufacturing, warehousing, and distribution act as one system. NVIDIA's Physical AI Data Factory Blueprint transforms this from concept to a standard practice by converting compute into physics-grounded synthetic training data at scale, cutting robot training iteration cycles from weeks to days. Our mega omniverse blueprint means every future factory will be born in simulation first, designed, tested, and optimized in a physically accurate digital twin before physical deployment, with robot fleets and AI agents validated in virtual environments first. This will significantly reduce TCO and ultimately drive meaningful ROIs.
Right, thank you. I mean, this is a slide also from Deepu sharing about that for the future of factory. Not just only like AI factory brain, also with lots of the blueprint will be there with a lot of agentic AI. Thank you. So Dr. Iwamura, so what do you think from OT perspective, like what will be the factory floor look like, let's say in year 2030 or even in near age? Yeah.
So our company is really focusing on the, go to next, yes. Focusing on the equipment. Yeah. Our target is edge and the equipment. That is focusing on the point. And what is the important point is now equipment means if it's an inspection, just say false or true. But in the near future, it can ask to the equipment and it will change to the intelligent infrastructure, and it can tell the reasoning why it happened. And the point is 4 dimension. Now it can take care 3 dimension, but I'm thinking it has to be extended to the 4 dimension with the entire engineering chain. When you design the inspection, it has to collect the data and add the meaning. And even in the go to the operation phase, it also needs to add in the meaning with a different aspect, and it has to be adapted to the human readiness. That is the important thing. And when we reach these kind of things, we call the Gemba DX. Gemba is a factory floor digital transformation. That is we are trying to achieve in the future. Right. Yeah.
Okay, from 3 to 4 dimension, I think is another jump lead on that is very amazing. So from a Advantech point of view, I think it's a great ending because we, again, 3 come together must be for some reason, you know, that we talk about AI factory brain. That from Deepu, from Miller, also I think early this morning, even though you did not join Jensen's keynote, you can watch the video, we talk about that. I think the future of physical AI is AI factory brain, because everything will implement it in the factory. With AI factory brain, from Advantech point of view, we partnership with NVIDIA, together with the Nemo Cloud, and of course with our WISE software. We develop a lot of agents. We only put some of them over there on the agent, and AI agent help Advantech factory, no matter on the automatic flow or also on the workflow or even on the SOP wise. And the other side, from Umang side in the future is that because you are the only one so far, the world first. We don't know who is the second, that you can have that use VRM for the mix of AOI, XI for the 3D inspection. That's very important. So which means that in the future of the factory, we will embed Advantech AI Factory brand, and together with NVIDIA technology, Nemo Cloud, and also the blueprint, and with the AI agent, and with Umang machine. So we expect that year 2030 is not 3-dimension inspection, it's 4-dimension. So to summarize, to closing our panel, the physical AI for the future, of course, everything is possible. But down to the factory floor, I think we need to make sure the AI factory brand is implemented, not only in Advantech, also around the world. And if I'm looking for the partner, I think Advantech Factory will be the one together with Middle support, KC support. I think not next year, I think very soon, within few months, welcome everyone to visit Advantech Factory to see how we implement AI Factory brand, and together with NVIDIA technology. And very soon, we are looking for the new machine from Umang. Thank you.
Thank you to all our panelists for valuable insight. Thank you. And please return to your seat.
We have to take a photo. Because there will be a wonderful moment for 3 parties all together.
Thank you once again to our distinguished panelists for valuable insights. Thank you for sharing with us. Please return to your seat. Thank you. We will explore how AI is empowering the next generation of the intelligent machines. Now let's turn our attention to another key topic, how AI is revolutionizing the factory floor. In our next panel discussion, AI powers smart automation for scalable transformation brings together 3 industry leaders to discuss the future of manufacturing. Please join me in welcoming our distinguished panelists to the stage. First, let's welcome Mr. Chingpo Lin, Vice President of the IoT Automation Sector at Advantech, and Dr. Miroslaw Ryba, Industrial Product and Construction Leader at Deloitte, and Mr. Praveen Tamang, Global Head of Automation Software at Bosch Rexroth. Thank you for coming today. And now I'll hand it over to Chingpo.
Okay, good afternoon, everyone. Today, I'm very happy to invite our strategic partner, Miroslaw from the Deloitte and Praveen from the Bosch Rexroth.
Hello, everyone.
Yeah, to sharing their perspective on the AI-powered smart automation for scalable transformation. So today we would like to talk about a very interesting and a very important topic in the smart automation. It's autonomous manufacturing. So to enable the autonomous manufacturing, from my point of view, 3 the key elements are required. First one, real-time control must from the closed system to the open, and the AI infra must from the cloud to the edge. And third is manufacturing operation must from the automation to autonomous operation. So today we will share the different perspective on this transformation. So before we talk about this topic, I would like to talk about market trend first. So in the past, everyone talk about automation, where we talk about Industrial 3.0, Industrial 4.0, but now never about talk about the Industrial 4.0, 3.0. Now, if you join the major global automation event, everyone talk about AI and software-defined automation, SDA. So it means the focus is shifting from the efficiency, visibility, to the autonomous decision making. So, and the next, I would like to ask Miroslaw, from your point of view, AI, how do you see AI is transforming in the manufacturing operation in the future? Okay, sorry, I have one slide I would like to share before I ask. Sorry. So another one topic is the Edge AI infrastructure. It's a very hot topic. It's a very hot topic for the autonomous manufacturing. So, and Edge AI infrastructure for autonomous requires importance is the high performance computing. It's the basic, it's the foundation. And then must have a strong software stack, to support the real-time intelligence, data orchestration, digital twin, AI agent, and the intelligent operations. So with the strong software, and it can enable these applications. So this is why Advantech continue investment and the WISE and the WEDA, and just cases mentioned. And Advantech is focused on the application layer. So we must provide Edge, I call it domain Edge AI as a platform with the software to help customers to develop their application. So this is an overview from my point of view for marketing Chang. So may I hand over to the Miroslaw? Can you share from your point of view, how do you see the AI transformation in the manufacturing operation?
Yeah, sure. So as you rightly said, AI revolution is on its way. And the numbers are growing. Today, it's over 800 million people using AI on a daily basis. It's 10% of the population. And because of these numbers are growing, it attracts investment. So there is more and more money invested in the startups which are building AI solutions. That's why these AI startups are growing faster than SAS startups a few years back. And this investment also drives the whole token cost to go significantly down. So over the last 2 years, the cost of a token went down 280-fold, which means it's a humongous change. But at the same time, the companies are paying more and more for their AI processing power, which means that they are completely not ready for the proper at-scale deployment of AI solutions yet, which means that they need to rethink their strategies, how to find the proper mix between cloud, on-prem, and edge, which is the big topic today. And the good thing is that when we see across different industries, and especially manufacturing, we did this research quite recently, where the AI is implemented today. And we see AI is present in different clients, in different areas. But when you look at AI, Agentic AI, it's used only by 11% of companies, while over 50% are experimenting, which means that they are preparing themselves for the future. At the same time, when we read the reports, Gartner just predicts that this very year, 2026, it's going to be over 40% of AI projects will fail. And they will fail not because technology doesn't work. We see it does, because we've seen it before in the sessions, that technology works. The problem is companies are trying to deploy AI on their processes, their organizational models, which were built and designed for the times where there was no AI. So without proper deployment of AI, with the proper transformation of their organizations, processes, governance models, they will fail. And that's exactly the role of the partnerships such as Advantech, who is a tech partner, and Deloitte, who is a business strategy implementation entity, where we can together help companies change the landscape and deploy the technology, right technology in the right format to change their business models. This is the only way for companies actually to pass this stage of proper deployment of AI.
Okay, thanks, Miroslaw. So I'm very surprised from the Deloitte report. Sorry, maybe I can back to the previous slide. From the Deloitte report, you can see 11% AI agent. I'm very surprised. But from my point of view, maybe just only 2 or 3%, but from the report we can see it's already 11%. So I believe this is AI agent will be growth very first in the coming years. So next, I would like to ask Praveen, how do you, I believe for Bosch, Rosford have a very powerful control software. But from your point of view in AI areas, what are the opportunity and the challenge in the coming years?
Yep. Thank you, Chingpo. Firstly, it's a great honor and pleasure to be here. So thank you first for having us here. Actually, I used AI. I put the agenda of today's conference and asked, give me the buzzwords that are going to come out today. And so this, is the vision. So let's say, I think we all agree, the whole session this morning, this afternoon has been about AI and how AI is going to really transform the industry. And the picture you get out of it is what you see here. So it's like a very, very clean, modern environment. Data is flowing seamlessly from IT to OT layer. Everything's interconnected, and it looks really modern and, yeah, a perfect world, right? So I'd like to talk a little bit about the reality. So if you give a reality check, the constraints we see, and we heard about that also in the session before about how there is a huge disconnect between IT and OT. So operational technology is probably lagging 20, 30 years behind, or maybe even longer. And that's where you have a huge gap, and this means that most of the AI projects, so how do you go from pilot to production? So there's a term, it's called the valley of death. So that means that most or many pilots never scale. And the reasons are because you have monolithic architectures, you have legacy platforms, vendor-specific protocols, there is no access to data, and you simply cannot scale because scaling it is so complex and so expensive, so it's not possible to scale. And not to mention cybersecurity. We have not heard cybersecurity today. So I want to be the bad guy bringing in this term here. So we have to think about cybersecurity as well. And these are key challenges we see. And afterwards, we will be talking about how we see the path forward in bridging this.
Okay, thanks, Praveen, is sharing. So Praveen addressed several challenges. But from my personal point of view, we can see the challenge. We can also see the business opportunity, right? So, so from my point of view, we need a new architecture to address this challenge, and then capture the new business opportunities. So in the traditional automation, everyone talk about from the sensing device, I/O control, SCADA system. This is the traditional SCADA automation architecture. It's still important. It's still important. But for the AI areas, we must new Edge AI stack, include from the infrastructure, industrial application system, and data orchestration, and AI agent development platform to develop the different kind of AI agent application. So we need hardware architecture. We also need to think about this new AI stack architecture for AI applications. So I would like to give you an example. This example is our Advantech control system platform with the digital twin. So in the past, everyone talk about the digital twin will be said used on the demonstration, virtualization, just a beautiful demo for a customer. But this solution, we combine the real-time control Cortex and the NVIDIA Omniverse on a single platform. And the customer can real-time control digital twin and AI. So, and allow the AI to continue scene to real to scene the loop. So we have a live demo at the Computex. Please come and see it in live. So next, I would like to ask Praveen. So maybe everyone know, both of us will have a very powerful control X software for the edge computing, edge controller. So can you share from your point of view, how do you see the software device automation, and how do you see Control X, this platform software can address the market?
Yeah, and I'd like to talk about how or what is the disrupting influence or our thinking behind the platform Control X that we built. Now, if you see on this video, and it's a YouTube video, it's not from Bosch, but it just shows how this transformation has taken place at your desk, right? So coming from the office where you had a physical device, like a contact firm or whatever, everything's moving and getting into an app. So this is something that, and this timeline stops at 2014, and this already happened then, you know. So, and that's the big divide between IT and OT that I was talking about before. Obviously, some things you cannot digitize, like your sunglasses and your smartphone. But after that, a lot of changes happened. And so that was like, you know, the philosophy behind where we said, that was around 2017, that we said, let's start with something radically new. So how do we, if you were to imagine software architecture for the future, for OT, bridging IT and OT together, how would we do it? And this is the result, was we built the OS, the operating system, for the smartphone of the future, smartphone of automation, sorry. And this is a radically new approach of basically doing IT, OT automation in a way, as you all know from your own smartphone. So when you want to, when you need a communication app on your smartphone, you go to the app store, you download the app, and then you can communicate. If you want to use, I don't know, a streaming device, then you just download another app. And this is really the thinking behind ControlXOS. So it's obviously real-time capable. That's where we are coming from as Bosch. That's our legacy. But it's based on an app-based architecture. So everything is built around apps. And the IT thinking is behind the platform. So we have a web-based engineering. We have an API-first approach. And there's an SDK which supports all major modern programming languages. And not to mention, very important point here is that it's CRA, Cyber Resilience Act ready, and we are certified to IEC 62443, SL2. We were talking also a little bit about the technology partnerships that we have on silicon. So this operating system is ready to deploy and able to run on Intel, AMD, x86 architectures. So you can just deploy it and it runs off the shelf. And just 2 weeks ago, we launched our first ControlXOS deployment on NXP. So now it's also on the IMX9 family. Yeah, then after that, what do you do with that? So you partner with the world's leading hardware manufacturer with a very, very broad portfolio. And this is the vision that brought us together, Advantech and ControlXOS. So how do you, what do you get by combining the most open ecosystem that we have with the very broad modular and scalable hardware portfolio? So that's really the vision behind it, to create together a ready-to-sell solution that you can just extend with software without having to do complex things with hardware. So there's a bold statement maybe up there. So future ready starts here, and this is really the point. So as you all know from Advantech, you have a very edge platform with many devices. We are already enabled on 3 and more to come. And I'd like to explain a little bit about how the ControlXOS architecture is built. So basically, at the bottom, you have what we call the device layer. And what we've done is we've abstracted the operating system and the software from the hardware layer. So it is totally hardware agnostic, but still real-time capable. And the beauty of this is that we have a native ControlX data layer. So basically, all the devices or end devices which are connected to the operating system, the data from these devices, whether be it a sensor, a valve, a PLC, is available in real time on this data layer. And this is what enables us to basically, what do we say, software defines the functionality. And so this is really, I'll just give you some examples of what we mean by that. Now, imagine there's a hardware layer, you have the operating system on top, so exactly like in a smartphone, now you want to build, let's say, an IoT gateway. So you would download and just apply. I've just taken a selection of 3 or 4 apps here. So depending on your use case, what you want to achieve, you would download the apps off the shelf, and then you have an IoT gateway. We also have, again, with the same app architecture, apps which would support communication protocols, standard ones in the industry, MQTT, Profinet, EtherCAT, and so on. Again, it's a software app. So you can add that, and with that, you can immediately connect securely to all the endpoints and devices that are there. Once you have the data, and we talked about it all the time, so you want to also transport it somewhere. But how do you do that? You need to do it in a secure way. So then you add 2 security apps, like VPN and a firewall, and then suddenly you have a secure gateway. And this is basically how you can scale your functionality by just adding software components to it. Another example, also, we are coming from a time where PLCs were hard-coded. So a PLC was a piece of hardware with the software, everything fused together. And that was the functionality of this hardware. Now, in this concept, the PLC application is just another app. So suddenly, you're starting with an IoT gateway, you made a secure edge gateway out of it, and now you want to add some control functionality to it. You download the app, and then you can combine everything on one device. So this is the thinking of software-defined automation. And now I hand over to.
Okay, thanks, Praveen. So, thanks, Praveen sharing. Many people ask me, what is software-defined? I always tell them it's from the hardware central to the software central. So software central need by the IPC, right? Need by edge computer. So this is very interesting and it's huge market for us. So next, I would like to jump to the hard topic, AI agent for autonomous manufacturing. So I believe everyone agree Nemo Cloud is become one of the public AI agent development framework. But the big question is, but how to build up domain AI agent? The key elements are required: thinking, connect, and the skill. So thinking leverage the LLM AI model, and the connect, linking AI agent with our edge computing, I/O equipment, or OT, the device, and IT, the system. This is our IoT core competence. And the skill must include the Edge AI and the domain knowledge, such as the vision, inspection, PHN, machine control like this, to build up and then to build up different kinds of the AI agent. So today I would like to take a production operation optimization as an example. So this is a AI production optimization engine for a semicon wafer test. So you can see the AI agent is had a normal eardrop, and the AI agent analyzes data and identify the root cause. The root cause is the prop car temperature is rising, and then AI agent automatically take action to the auto parameter adjustment, dynamic scheduling, maintain notification, and continue the learning, and line recover to the normal. So this is a very simple example, but it's very powerful. And I believe that in the future, AI agent will be like the digital employee in the factory to driving the autonomous manufacturing. So next, I would like to ask Miroslaw from the Deloitte point of view, how do you see AI agent is transforming for the autonomous manufacturing?
Actually, we start seeing these solutions on our clients, which when we work with them worldwide, more and more clients are actually hoping to achieve and gain more value by adopting AI, agentic AI on the shop floor. And there are huge hopes that smart manufacturing will help them reduce the overall cost of operations, improve quality, and increase the top line of the businesses. And this is something what we also observe across the industry, and we write about it in the report that we publish annually about the trends and the challenges manufacturing clients are facing worldwide. And to be frank with you, AI is in this report all over the place. Because today CEOs and boards perceive AI as a game changer, not only on the shop floor, but they also believe that AI can help them overcome the challenges, the supply chain issues, which we see today and observe today as we speak. The CEOs hope that AI will help them address the proper service transformation for their customers, their clients, to better understand their needs. They hope the AI will help them the investments that they are planning in the future. And they also see the fact that today all the manufacturing clients need to compete with hyperscalers, with other client sectors, with the banks for the talent. Because today manufacturing is not anymore about blue-collar workers. It's about skill set, which will help manufacturing companies actually harvest the value of AI and bring AI to action to actually help them increase the top line and reduce the challenges across the operating models. And what we also see is that there is still a huge chance and opportunity for all of us as we sit here, because where we are in terms of the value that companies are harvesting from AI versus where the hope is a huge. As we can see here, the only area where the AI is bringing value comparable with the expectations is around the efficiency improvement. All the other areas, we're talking about improving the cost savings, improving the top line. It's the gap between where AI is today versus where the CEOs expect it to be. It's humongous. And this opportunity for us is huge. That's why we have built at Deloitte the framework, which helps actually harvest this value. And this framework is divided into 3 layers. The business domain, how to help clients work with their business operations, how to optimize their supply chains, how to improve their CRM systems. And the core of it, the heart of it, is what Praveen was mentioning, this IT-OT convergence. The shop floor operations, how to actually design, implement, and operate the whole shop floor MES system, SCADA, PLC as a software, right? That's the big challenge, how to properly deploy robots on the line to improve the value from the operations. And the third layer is about how to actually help the clients bring the modern technologies such as digital twins, AI, to their daily operations with the whole component of cyber supporting this and building the resistance of this model, plus all the legal aspects for the tax benefits for this change, because this investment can be offshored from the tax perspective. So this model is something what we successfully deliver and deploy worldwide. But the key feature of it is, first of all, client centricity, because it's all about the end customer. And the second success factor of this framework is that we managed to build partnerships. We managed to build alliances, such the one we have here with Advantech, where we can jointly go to clients as the set of entities, companies, helping them address their pain point, their business problem. And as we have discussed before this panel, to share some cases, right? So I was struggling to pick the one, so I picked 2. And the one is about emphasizing what Praveen was telling before, the importance of data. Today, the companies are struggling with the issue of building something sophisticated for the future because they don't know what's their data landscape as of today. And for one of the companies that we worked, the large food manufacturing company, at some point they realized they want to go to the 21st century. with the all data, AI, sophisticated models. They were dreaming about the digital twin, but we had to start their journey from the point where they were. We had to analyze their shop floor operations, their processes, their technologies, just to be able to build this process control tower where they were able to grasp the real picture, how their operations across their plants look like. And from this point, they were only able to start the journey onwards to design the proper AI-driven predictions for the demand, for the planning, for the digital twin, for the plants, etc. So this is something where I wanted to share the importance of making the first step, clearing and cleansing the whole data perspective of the company. And the second case I wanted to clearly share is something what emphasizes the need of collaboration. That's the client that together with Advantech, we developed from the idea that they need to improve, that they need to transform their operations to the point where we're actually signing the final documents concluding the project, where we actually deployed together the whole transformation from the high-level vision of the company with the integration with their ERP systems, robots on the line. We brought and delivered all the IT infrastructure, OT landscape. We transformed their OT operations, and we were in the heart who designed it, and partners like Advantech, you deployed the hardware and all the components which we together were able to deploy. And today, the client is, when you compare them where they were 2 years ago versus where they are today, there are two different companies. The only common thing is the brand.
Okay, thanks, Miroslaw, for sharing. So just Miroslaw mentioned, I would like to point out the very important thing is the ecosystem. So I believe you will be joining Advantech new SI ecosystem partner program, right? Just like Casey mentioned earlier, we have a new SI partner program, so I believe you will be joining, right?
Yeah, we are. You can count on us.
Okay. So next, I would like to talk about AI at the edge. So AI at the edge is a big change. Just I mentioned earlier, cloud to the edge. Everyone talk about the edge AI, but I would like to say, if you would like to make it happen for a different kind of domain, you need domain edge AI system. Just the Miroslaw mentioned, we provide robotics. But in this time, I would like to take the vision as an example. So our vision expansion system, just for ICANN, we integrate optical and vision sensing and NVIDIA JSON, GPU, CPU, and our vision software stack. And this is we call the domain edge AI system. This is the vision expansion AI system. So we will continue to provide a different kind domain edge AI system and with the software. So I would like to take an example for this project. And this is the real case from our search partner overview of AI. Traditional vision expansion must spend a lot of the human resource to the training and segmentation. But this is the solution. Customer just is the auto segmentation and one-click training and the real-time inference. So it can help reduce a lot of the human resources and improve their inspection accuracies. So, and the next I would like to ask Praveen. So can you share some of the real case for the edge AI applications?
Sure. So actually from our perspective, whether it's an edge case, edge AI, or it's on the embedded or in the server, it doesn't really matter. So it's really a question of the architecture. So if the architecture is scalable, so then you can deploy, as we say, almost anything. I just brought some examples here, and again, we are also working very strongly in this open ecosystem approach. And currently, we have more than 100, actually 120 partners right now So also for vision, we have, I think, around about 10 partners. And all these examples that you see here, from printing machines, quality inspection, even to warehouse automation, detecting people, dangerous situations, accidents, but also into building automation. And this just shows the scope and the scalability of the architecture. So basically on the same, you could even take the same hardware, and the baseline is the operating system, and upon that, you can build many of these applications. Simply, again, I have to emphasize, by downloading software apps. So imagine you want to connect and you want to build a vision application for quality inspection. Now, in the real world, there will be different cameras, there will be different sensors. So, and then again, you go there, you download an app, which then connects to, has all the hardware drivers, so you can connect to the cameras. And then you have another app which does the annotation of the data, and the third app where the model is running. So this is how we kind of understand and have interpreted software-defined automation. And so basically, the combination possibilities are infinite. And the ecosystem is growing very strongly. And yeah, we are part of your ecosystem, you are part of our ecosystem. That's how we grow, yeah? And lastly, again, Mirek talked about data, and I want to, again, highlight this. Talking about the pilot to production gap. So how do you really close it? And I totally agree with you, data, data, data. So it's about data access, it's about data security, and it's also about data scalability. So if you have to, build something complex, then you can do your POC, but you want to move from one location to the other, from one line to the other, and that's where complexity comes in. There's added layer of middleware, added layer of software code that you need to just write in order to just access the data, and this makes the TCO, I mean, nobody can finance that, and therefore, architecture is the key, and this architecture should enable you to access data very, very, in a very, very simple way, without adding further cost to it. So you can just download the app, and it doesn't matter if it's a third-party device. So any of the devices that you see here, it could be an HMI device, it could be a third-party PLC, it could be anything else. But with the data layer and with the software applications that you download, you have access to the data immediately across your assembly line or whatever you're trying to connect. And then you can build your AI applications on top. And again, as an app. And and the model is really, or the architecture is really also AI vendor agnostic. So AI models are transforming, changing every 3 months, every 6 months. So who knows which model is going to be the coolest one next year. But again, if you can deploy it on the edge, then you can do it simply by updating it on your app infrastructure. So that's my key message for today.
Yeah, thanks to Praveen. So I believe AI will be optimized at every stage of the manufacturing and enable the closed-loop optimization for the autonomous manufacturing. AI is coming to the smart automation, and we will commit to investment in this area. And I believe Advantech will commit to work with the partner to capture this huge opportunity. Thank you, everyone.
Thank you.
Thank you to our distinguished panelists for those wonderful sharing. Thank you. And now let's take a picture together. Thank you. Thank you, and thank you once again to all our distinguished panelists for those insightful perspectives today. Thank you. And this concludes today's conference. Thank you all for being with us today. Thank you.
We want to bring something interesting.
Okay.
Yeah.
All right, this is MC. So let's have a last panel discussion today. Here I would like to invite Areoll and Areoll, please, on the stage. Sit, please. All right, our topic today is powering edge AI in healthcare and retail, and also the smart services market. Okay, in last two sessions, we learned about how the edge AI make the machine and automation, the factory, smarter. But when it turn into the service industry, the edge AI needed to serve people directly. And you know, sometimes people are emotional and unpredictable, right? So that's, in this industry, that the AI solution needed to be accurate. That's the put mentioned about several times. Needed to be accurate and intuitive in the real practice. So let me first of all share with you about what service iService sector is doing. That's aligned with the Advantech corporate directions. That we build up the edge computing, and then with WEDAs to build up those utilities, and then go to the edge AI-powered voice solutions in healthcare and retail. So this is our main business in iService. So today, it's my great honor to invite two AI opinion leaders in Taiwan to share their insight in real practice. So first of all, I would like to introduce Dr. Du to all of you. Dr. Du is the CEO of AI Research Center of National Taiwan University. Not only for the academic studies, but he also supports the government and the industries to bring the AI solutions in real world. Okay, and healthcare AI is one of his expertise. So let's welcome Dr. Du. Yeah.
Thank you, MC.
Yeah. And my second VIP speaker, Areoll Wu. Areoll Wu is the Vice President of PIC and also the CEO of PIC Philippines. Okay, PIC is the IT company of Uni-President's group. Oh, sorry. Yeah. So that's, you know, Uni-President Groups is one of the largest retail groups in Taiwan that's operating more than 13,000 stores in Taiwan, that including 7-Eleven, Starbucks, and Carrefour, and Nokia as well. It just joined the Uni-President Groups. So Area is one of the key AI drivers in the PIC, that's to bring AI into the whole Uni-President Groups. So let's welcome Areoll. Yeah. Okay, so let me start from the healthcare part. Okay. So this is the blueprint of Advantech iHealthcare. So we provide the edge computer in medical computers, medical images, and medical mobilities. And then also the solutions across the inpatient, outpatient, OR in hospital buildings. So here in the high hospital building, I would like to share one famous project in Taiwan. It's called Capstone. Okay. This is a project Dr. Du built for National Taiwan University Hospitals. The project started from year of 2020 with 3 times investments. That Dr. Du built up 13 AI models for National Taiwan University in emergency cares. So in this project, it also applied Advantech Edge servers and our WISE platforms in building these AI platforms. So here I have 2 questions to Dr. Du. So first of all, would you please briefly share about these capstones? I know it's a challenging project to bring this 4th AI platform into National Taiwan Universities to connect all the fragmented data all together. So this is the first question, and how Advantech WISE support you on these platform buildings. And the second question is about the near futures. So how do we see the edge AI, like Agentic AIs, Nemo Clouds, those physical AI can support in future hospital operations and also the patient cares? Please, Dr. Du.
Thank you, MC. Okay, so I'm Edward. I'm representing the AI Research Center of National Taiwan University. So basically, the AI Research Center was founded in 2018. So there are 4 universities has an AI Research Center during that time, and we are the one in National Taiwan University. And our focus is on the core AI technology research and also the application on the healthcare. So let's look back at the history of healthcare. Basically, we all know that in the past, all the healthcare was performed by human, and all the process and procedures were designed for human. But when we come to the PC era, so we start to use the digital tools, and more like our storage, inspection, and with the AI, powerful AI tools, we can perform the predictions on some disease. So right now we are at a turning point of predictive AI to go to the active AI agent, agentic AI. So right now, when we look at the technology roadmap, we see that from machine learning to predictive AI to generative AI, and to the multimodal large pre-trained model to the current active AI agents. So the point I want to present is that it's not only we choose the most updated technology, we need to define the right question and select the suitable technology to solve that. So let me give a brief description about the Capstone project. The project is designed for, we want to develop AI technology introduced into the real hospital. And the problem is that we want to reduce, expedite the emergency department workflow. So maximize the throughput. And also we want to help on the administrative tasks. So at the right side, you see we did something like emergency dashboard, which gather all the real-time information and present it in visually. And we also construct the emergency bed positioning and the management system. So at the right side, you can see there are more than 170 beds we establish, and we can display the position and associate with the patient information. And the left-hand side you see is more like we identify 6 key nodes in the emergency patient journey. And then we develop 13 to 14 AI models. The most important thing is after the models, we need to integrate all those models running together in a uniform software, which is the clinical decision support system, and deploy in the hospital and connected interfacing with the hospital daily operating software. So this is the most important things. And the last things we think that it's critical is doing the real hospital validation and clinical trials. So this shows how we map those technology. From the patient arrival to the patient departure. So in the triage stage, we developed several models, including like triage level predictions, the length of stay estimation, and the mortality probabilities, those kind of things. And in the diagnosis stage, we developed the ICD-10 diagnostical predictions, and also the chest X-ray prediction, three chest X-ray prediction models. And then at the observation stage, we developed several models which provide the probabilities and the possible warning to the physicians. And alongside with when the patient stay the longer time, we collect more data. Then we can have a more accurate predictions at that. And of course, we have also have a special event which handles a cardiac arrest prognosis predictions, which also won the National Innovation Award. So this just shows you that for the triage models, right now all the emergency department use the typical TTAS 5-level triage, but you can see in the left side, a majority of the patient was categorized as a level 3. So in such a case, the typical TTAS leveling cannot prioritize the most critical patients so far. So that's the reason why we did that. And also we developed the ICD code predictions and the models we transferred to the NTU hospital, and they continue to improve the performance. And in 2023, they involved the large language models and make it more reliable, and right now it's still used in the hospital. And this shows that the 3 chest X-ray models, and the different things is that in the emergency department, a lot of patients come in to the ER, they laying on the bed. So we use it as a mobile X-ray machine to take the photo in the supine AP view. So this is more difficult than the upright view. And this shows that the safe disposition. You can see that alongside when the patient stay the longer time in the ER, so we collect more data with exam result, with some lab data, with more vital signs. We can give you a more accurate AI performance. Okay, so then we see that after we developed so many AI models, and the most critical things we experience is that we need to integrate it into a unified clinical decision support system. So you can see on the right side, we build the emergency private cloud, which runs the WISE-PaaS platform to support all the AI models and local storage and the inference user interface. But at the left side, you see we need to interface with the typical hospitals' HIS data, RIS data, and PACS imaging data. So the problem is that it's quite difficult because we need to get all the real-time records from the real hospital. So fortunately, we get the support from the IT department in hospital. So they help us to customize tens of APIs, real-time APIs, and also they develop the real-time de-identifications and encryption and decryption algorithm such that we can extract those data onto the WISE-PaaS platform, but still keep the privacy information. Okay, so this shows that we successfully interface with 14 subsystems and 49 structured data tables and at the real time, and more than 120 emergency physicians participated in this program. And we can achieve that, update all the AI models for every patient and support simultaneously more than 500 patients in 3 branches hospitals. And we conducted the clinical trials and for 6 months, and more than 60,000 patients use this platform. So just give you a key breakthrough of the experience, we see that there are four key elements when adopting AI technologies, but we see that the compute and the AI models is easier to manage. The most difficult things is for the data, and we need to get the domain expertise, which is come from nurses and also physicians. So at the left side, you see that when we introduce the AI models, we want to get the high accuracy, but most importantly is effectiveness. So if we just have a high accurate model, but when we apply to the hospital, if the patient cannot get the advantage from the AI outcome, so it's not effective. That's what we say. So doing the real world validation and clinical trial is very, very important if you want to introduce the AI in the hospitals. So this is to answer MC's questions. Today, everyone is talking about the AI agent, and we know that for AI agent, we need a very smart, intelligent brain, and which can do the reasoning and the planning for complicated situation. And we also need to have a brain which has the enriched medical knowledge to support those diagnostic and summary, those kind of tasks. And to summarize that, we can treat it, make it as 5 categories. Agents for caregivers, like a physician and nurse, agents for patients, and a big portion is the agent for workflow. And in the bottom, which is an agent for security, I mean for safety and cyber security, we definitely need that. And last one, we also need the agent for the value up, which can empower the physician and the nurse. Yeah, so I think this is what I answered the question from MC. Thank you.
Thanks for Dr. Du. So that from Dr. Du's sharing that in Capstone, you can see it's not only about the OT and IT or AI connections. Actually, it's really a kind of orchestrations between those domain knowledges and IT platforms. So that I do believe Advantech WEDA platforms can continue to support the Capstone's projects ongoing in the national town hospitals. Okay, and also look into those future edge AIs. Yes, orchestrations, autonomous, and seamless collaborations across those AI agents in hospitals. We do looking forward that in the future that how those edge AI can empower the doctors and also enhance the patient care. Thank you, Dr. Du. Okay, then let me move to the second verticals, the retail. Okay, so sorry. This one. Yeah. So same as what we have in the iHealthcare. So we have bunch of the edge computers that can cover most of the front store applications. And also based on Vision AI and also VLMs, LLMs, now that we have those solutions in digital signage, interactive digital signage, voice ordering, and loss prevention, those solutions. So that's in the real retail part, I know most of the big retailers, they are eager to have those AI solutions to improve their efficiency, especially during the labor shortage areas. Okay, but I do believe most of you don't fear what kind of AI is supporting you nowadays in the retail stores. But I learned from Mr. Wu that actually in United Presidents groups, they have implemented a lot of AI technologies in the whole operations. So here I have 2 questions to Areoll. So first of all, United President groups provide end-to-end services in the retail market. So they have full factories.
they do the transportation distributions and also the front store operations. So as a key AI driver in the groups, so what are the key strategies, directions that you are going to bring AIs and to AI applications across the whole groups? And second question is same as what we have in the hospitals. So how do you see the Edge AI, that Agentic AI, Nino Cloud, physical AIs will shape the futures in the front store of customer services and customer engagements? Yeah, please, Areoll.
Okay, thank you everyone, and thank you for good question from MC. Actually, in retail, it's very high manpower demand area. So now, especially in Taiwan, the manpower is about the shortage issue right now. Yeah, so we have faced about many challenges in three, I think in most of in store and also about the logistic, especially about the warehouse. Yeah, but luckily before 3 years ago, there's a genetic AI coming, right? And it's come from, start from OpenAI. And during the time, we trying to build up about the AI system with RAC and trying to implement about store system, logistics, and e-commerce. And we make sure about some of platform we can training ourselves. So detail, we can cross different region depend on the store and logistics and e-commerce. We using about the AI, Agentic AI to integrate together. So let's see about the first one. In the store system, first of all, I think very important thing is how we increase about the sales. So most of the budget we putting on here. So for example, how we do about demand forecast. Now most of 7-Eleven store in Taiwan, we are using AI ordering. It means in the POS and also store computer. Store computer, I think most of store computer now we are using Advantech. Yeah.
Thank you.
So this is first. And second one, now in store computer, we trying to doing about demand forecasting. For example, how many SKU right now for the fresh food we need to ordering. So this is the thing how we can increase about the sales. And second one, we integrate with many AI IoT. For example, like self-checkout system. Yeah, and the last one, most of strategy we are doing about the AI intelligent, ship intelligent. Especially now employee, they doing about checking about the ship. They just need to using about the app, trying to get about all the image we share, and all the report can come out immediately. And this is very useful to know about what is the SKU out of stock, and also the SKU put in the correct location. And especially if we are moving to the logistic, now most of logistic we are doing about automation already, like AGV and also the auto storage system. And second, now we're trying to focus on the traffic management system. And all the truck we put about the, it also is about the Advantech about traffic PC, right? Yes. Yeah, trying to get about recall and know about where is the driver and the goods delivery on time. So that's the strategy. It's not only in Taiwan. We also right now implement in Philippines. Yeah, because Philippines, we also own the 7-Eleven right now. So this is about the ongoing project we are working on. And the last one is about the e-commerce system, because since last year, have many LLM model, so we're trying to training our own LLM model with embedding system, especially all the skill and product information we train together and try and come out with like a recommendation system and relinking system and make it about the more efficiency from e-commerce system. Okay, and going to next question. Since now about the Edge AI, I think Uniperson is the one in Taiwan doing unmanned store. It's from a few years ago. And coming this year, we already have a 9 store. We're talking about the X store. So X9 store right now are located in the National Central University, and X8 store is in the National Ocean University. So those kind of store we're doing about like a pick and go. But as we know, pick and go is a very long time ago from Amazon, right? So all the Edge right now, they just using about, most of its camera are doing about the user checking and pick and go, what kind of product you pick up. But I think for next future, we thinking about the future can be like physical AI coming soon. So that's why in this page I put about the robot, because now manpower is problem. Even no people can do about restock, because in the pick and go from Amazon Go, most of things is focus on how to sell and how user can doing about self-checkout. But a very big problem is how to restore about the goods. I think is more important. And second one, now we're trying to doing about a virtual store. How we using about NVIDIA Omniverse with Isaac, how we can realize the offline and online omni-share. And we can actually control with robot together from the NVIDIA Omniverse environment. So that is our strategy. Thank you.
Yep, thanks, Arias. So that's actually in the store operation is not only about the unmanned store. So this topic raised up by Amazon with Amazon Go, you know, how long? Few years ago. But why it's not really implements everywhere now? That's because it's not only about the casuals. It's about the operation. It's about the logistics, about the shelf management. It's about the customers interactions. So that's, I do believe, with those Edge AIs is coming up, and Uniperson groups that they have different kind of store across in these verticals. So convenience stores, food and beverage, and shopping malls, and also the hypermarkets. So with these engagements, I do believe, I do hope our WEDA platforms and our edge computers can continue to work with PICs together to bring different kind of edge AI and AI agents into different kind of type of retail stores. Okay, thanks.
Yes, thank you.
Yeah.
Thank you.
Okay, so here I would like to use this last page to conclude today's sharings. Again, Edge AI is coming. It's not only in the factory, in the machinery. Actually, it's happening everywhere. So that in the healthcare side, the precise and accuracy is important. In retail side, efficiencies and also the hospitality is also important. So they need different factors in different domains, in different verticals. So that's with Advantech Edge Computing and our WEDA platforms. So I would like to encourage all of you that please join our partner programs, that our WEDAs, our edge computers, and then can work together with your expertise to bring the edge AIs realized in all the verticals, all the domains. Thank you very much. let's thank Dr. Du and Mr. Wu again. Thank you.
Thank you.
Thank you, MC, Dr. Du, and Mr. Wu, for those wonderful sharing and valuable discussion. Thank you. And thank you once again to all our distinguished panelists for valuable discussion today. Thank you. Now we come to the end of today's conference. Thank you all for being here with us today. And tomorrow, June 2nd, Computex 2026 officially kicks off. We also invite you to visit the Advantech brand Pavilion at the Nangang Exhibition Center Hall 1. And we also have more exciting events coming up this week, including our WPC on Wednesday at the Advantech Lincoln campus and the Computex Forum on Thursday at the Nangang Exhibition Center Hall 2. Before you leave, don't forget to stop by the social engagement wall in the lobby and subscribe to Advantech's YouTube channel. Thank you all for joining us today, and we hope to see you again soon.
On Wednesday.